desert in the great American Southwest, I bid you all good evening or good morning, as the case may be. It's great to be here, better here than Puerto Rico, where the winds are screaming. I talked to Seth Shostak, who's not in Puerto Rico right now, because he said, well, we watched this thing churning across the Atlantic Ocean. I talked to him about 10 minutes ago, and he said, at the time, the wind gusts were around 200 miles an hour, and he said Arecibo itself was only meant to withstand 200-mile-an-hour winds. And so that's it. We packed up, they closed up, we got out of there. SETI is obviously not manning the Arecibo telescope at the moment. As a matter of fact, probably all you would see would be boarded up windows and that sort of thing, with hurricanes screaming through the island. There are already 3 dead in Puerto Rico. To the business at hand, Richard C. Hoagland was an advisor to Walter Cronkite, science advisor. He was at one time a science advisor or advisor to NASA, where they now have large busts of him in the halls. People still salute as they walk by. He has been an investigator into things uncommon, but scientific for a very long time. He's on to a lot of really interesting stuff. And Tom Bearden are both coming. Tom Bearden, let me tell you just a little bit of what I know. He is a retired Army colonel, and what he is going to tell you tonight, a lot of it's going to be presented in the guise of theory and fiction. But I'm telling you all, listen to what Tom Bearden says very carefully, because I'm told read between the lines, because most of what you're going to hear is real. It is being presented in the manner that it is, probably to avoid people going to jail or something. So welcome to you, too.
Good evening, Art.
That would be the voice of Richard C. Hoagland in New Mexico.
Hi, Art.
And that would be the voice of Tom Bearden, a physicist with a big black ops background. And so as I point, is that a fair characterization, Tom, I gave of the information you're going to present, or should I retract it?
Well, it'll be just a little bit different. First of all, I'm not really a physicist. I'm a nuclear engineer.
Okay.
And second, I'm not really in the deep black so much. I had some intelligence assignments, but mostly in technical intelligence. In other words, we worked on what the other guys had and what we thought they might have. So but
if that's not black ops, then what is?
Well, it got into that area, but I'm not the type that out in the field.
Okay.
Sneaky Pete type.
I know, I understand that. But, I mean, I said, as we talk about some of the technical things we're going to talk about this morning, we'll present it as theory or fiction.
They're black enough, that's for sure.
Okay, that's all I wanted. That's all I wanted to know. Richard, where should we begin?
Well, let me try to give some context. You and, of course, the audience and Tom know for a long time, I've been looking at this field I term hyperdimensional physics, which most people, they stop me right there and they say, what in the world is a hyperdimensional? And so tonight, let me define it, all right? We know what dimensional is. We know what length and width and height is in the normal 3 dimensions of our existence. You know, living room furniture has a length, a width, and a height.
Yeah.
Freezers have length, width, and height, and all that.
Yeah.
Supposedly, there is a 4th dimension of time, which Einstein gave us via general and special relativity. But before that, back in the last century, in the 19th century, there were a group of scientists, physicists, mathematicians, and others, who were really playing around and toying around and thinking long and hard about more than 3 spatial dimensions, and therefore the term hyper. Anything that's hyper is beyond or above normal. So hyperdimensional means beyond 3 normal dimensions.
Okay.
And hyperdimensional physics means a physics which must encompass more than 3 normal spatial dimensions to be on the way to completeness, to be a unified model, a real model of reality. Well, many years ago, my interest centered on Tom Bearden because he was one of the few people, I mean really few people, that I encountered on the lecture circuit who was actually talking, A, about hyperdimensional physics, although I don't think, Tom, you used the term in those days.
I did early on, yes.
Okay, well, I caught you
it's
when
a good term.
You were into the scalar phase of your discussions at the point I caught you.
Right.
And then the other thing that Tom did was he introduced me to the real Maxwell, James Clerk Maxwell, who can be considered the father of modern non-relativistic physics. I mean, if you say the name Einstein, everybody thinks relativity. But when you say to most technical people and physicists and engineers the name Maxwell, they think of everything up to Einstein. Mm-hmm. So those two people are kind of like the super icons of the foundation of the world we think we inhabit in terms of science. Well, Tom introduced me to some pretty interesting things about Maxwell that I didn't know, and I'm sure that most other physicists don't know, namely that the Maxwell that we read about is not the Maxwell that really existed. It is a version. It is a kind of a 2D cardboard cutout of the extraordinary multi-dimensional universe that Maxwell and his colleagues were playing with, imagining, working with, trying to model, trying to predict scientific facts from.
Well, even modern-day theoretical physicists, best minds in the nation like Michio Kaku, who I interview all the time, almost thinks that a number of universes or parallel universes are passé. I mean, he's so accepted the fact that they exist.
Well, it has come back a long circle to where the idea of multidimensionality as a solution to the big problems of science, the big problems of physics, is once again in. It's once again de rigueur. Mm-hmm. But the difference is that where, Kaku and his colleagues talk about 26 dimensions or 10 dimensions, and you can't test them. There's no laboratory test you can propose that will decide whether their models, their hyperdimensional models, are real, because it would literally take more energy than there exists probably in one-half the known universe.
And he admits that.
Okay. The Maxwell multidimensional models we have discovered through Enterprise, through the work that I and my colleagues have been doing, and that then impinges directly on what Tom Bearden is going to talk about tonight, is incredibly, eminently, and blatantly testable. And that's where the two pathways, the two thinking processes radically diverge.
All right, I want to stop and say something to my audience. Now, for a lot of them, this seems like a bit much, but you have an extensive presentation paper now on your website about hyperdimensional physics, and I need to tell my audience that even people who hate your guts, Richard, and there
are... Make me sound like Bill Clinton.
There are a few. Actually, Clinton may have better approval ratings than you in some cases in the halls of science. Now, but these people, mathematicians, physicists, have been emailing me, and they say that the paper you have put up there is of great substance, great importance, deserves study, and nobody, even the people who hate your guts, have said that, have poo-pooed it. None of them.
Well, that's because science is democracy. And the ultimate purest democracy, it doesn't matter what personality you carry or what baggage you carry or whether somebody likes, the cut of your beard. The bottom cruel line of the universe is if it works, it's real. If it doesn't, it's not. And the thing we're going to get to tonight, beyond the theory, beyond the ideas, what Tom is bringing to the table is a whole series of engineering capabilities, implications for real machines and real devices and real breakthroughs and real-world implications for putting this hyperdimensional physics to work.
Yeah, I always ask you about that. Application. In other
That's where we're going to go tonight.
Oh, really? What can we do if hyperdimensional physics is real and the power can indeed be harnessed? What can we do with it?
Thomas?
Well, that's a good question, and the answer is you can do just about anything you wish to once you develop the technology. Let me explain just a little bit. we have actually two things ongoing in the discussion so far. One, the dimensionality of a model. A dimension is really not that extraordinary. It's just a degree of freedom, basically, when you come down. Something can vary in a certain direction. And mathematicians can work in any number of dimensions that you wish. But if you cut down the number of dimensions, what you're really cutting down is you're freezing the system more and more. You're not allowing it to vary or to function like it really could function.
Right. For example, if a human could only move in 2 dimensions, you'd be very limited.
You'd run around on the surface of the ground on a flat table. You'd never be able to climb a tree.
Exactly.
And it'd be hard to get away from the saber tooth that way. In other words, it does have some practical use. That third dimension does. So
I'll bear that in mind when I go to Africa next.
Right. But the thing is that we talk about then what...
Art, if we all lived in 2 dimensions, you wouldn't have taken your fall the other night.
It's true, but I wouldn't have had a porch either.
That's true.
This gives the audience some idea of what dimensions are all about.
The other thing you have is any model, any kind of theory, like the theory of electrodynamics or something, you pick a particular algebra that you embed the theory in. Now, an algebra is like a chessboard. It's got a certain fixed domain. It's got a certain set of functions that you're allowed to do. It's like a game, a special game that's been constructed.
Tom, let me interrupt just for a second. It's also like a language.
That's right. It's also like a language.
If you were constricted to pidgin English to describe Samoan sunset, obviously your audience wouldn't get the point. But if you have the King's English, or you have Latin, or you have, Shakespeare, you can be much richer in metaphor and texture and subtlety and nuance. I mean, the Eskimos have how many words just for ice?
Yes.
So mathematics and algebra is like a language in that the richer it is, the more you can use it to describe the real reality that surrounds us.
Well, the functions that come out of it, the more functions that it has, that makes it a higher topology algebra. Topology, all that means is look at it like a little flat piece of paper, only now you're able to stretch it and pull it like a rubber sheet and twist it and tie it in knots and so forth.
Well, here's a good analogy, Tom. Before we split the atom, we theorized, we did the math, and we decided the atom could be split, but we didn't know it for sure until we did it. Nevertheless, the math forecasted the fact that we were going to be able to split the atom. Isn't that correct?
That's correct. And as a matter of fact, Campbell, in the old magazine today, it's called Analog. It was called Astounding Science Fiction then. During the war, he just checked out some physics books, and he put together a little article about how to build an atomic bomb. Startled the entire Manhattan Project. Because he was right on, except he didn't know what the critical mass of uranium was.
Well, all I'm trying to get to here is, if we can forecast the splitting of an atom mathematically, then we can forecast Richard's hyperdimensional physics and what they're going to mean to us mathematically as well. And that's really what you're saying, I think.
Yes, and in particle physics particularly, you have to keep adding dimensions because you can't get all the crazy particles in that keep coming out of the experiments unless you do open up the model. You can't just stay in a fixed small number of dimensions. About the least you can get away with is about 11, and I think now it's up higher than that.
All right. Now, one big question is how we prove all this. And Richard really tantalized me with something. He said to me the other day, hey, Art, our deep probe spacecraft are not acting as they should act, given known physics. And I said, what? He said, yeah, gravitationally, there are anomalies that simply cannot be explained. And there's big news about our deep probe spacecraft. So when we get back, I think I want to head in that direction and see if that underscores the hyperdimensional side of physics and the other dimensions. And that's exactly what we're going to do. So that's the teaser line right there, folks. Our deep probe spacecraft have been found to be not operating as they should. In other words, defying the laws of known physics. Now, how can that be? Well, easy. There's something we don't know. I'm Art Bell, and this is Coast to Coast AM. Don't touch that dial. Going to cover deep probe spacecraft in a moment, but actually I'm going to preempt even that discussion for a second. Something we should have done at the beginning of the program, and I will now do. I'll do it by reading the following facts from Ontario in Canada. Dear Art, I would like to talk about John Holloman as unfinished business from last week. Like yourself, I too was very saddened to hear about his death. You know, I've watched him over the years and always looked forward to his upbeat, enthusiastic reporting style. Was glad for him when he was given the exciting space shuttle program to cover. You mentioned you'd be talking to Richard Hoagland Monday night tonight. Could you please ask him what he thinks of the vagueness and too few details given out about John's death? How it occurred. A man who survived so many earlier worldly close calls, to be taken out that close to home in such a manner doesn't make sense to me. Upon hearing the news after the initial shock wore off, the first question I found myself asking was, what was it that forced John to take such a profound risk on the road that day? He knew the road well, traveled it often, knew there was a no passing rule along that stretch of road. He was an intelligent, seasoned man, it seemed to me, who would just simply not take his life, his son's, into his hands unless he felt it was absolutely necessary. And the silly reason reported to People magazine just doesn't cut it somehow. Could someone else have been involved? Was something weighing heavily on his mind that perhaps distracted him? There really are many questions. And, Richard, we can't let the night go by without letting you say something about John Holloman.
Well, first of all, I was, as everybody else, shocked. I mean, you were the one to call me.
Yes.
And basically call my attention to the CNN bulletin, and you know I was stunned. I had been looking forward to John and Walter getting together. There had been some discussion, very low-key, of maybe me doing something on the mission with Walter and with John, just because it would have been so neat and so nostalgic, and it was something that we were keeping very quiet, and that obviously has all been cut short now. But in terms of the facts, sir, we don't want to leap to the sensational. You know, there are times when things so bizarre just happen. What I find equally bizarre is that a few minutes after Art, read us the details that we could get from the Constitution and from CNN of John's death, he walks out his front porch and it's not there, and he almost killed himself.
Yeah.
And it was really, you deserve a Darwin, because...
I know. But
that's what entropy does. Not everything is logical, not everything is rational, not everything looks like it makes any sense at all, and senseless tragedies happen all around us every day. As you know, I am spring-loaded to look for the C word,
Sure.
And I am trying very hard not to, just because if we squander the precious resource of searching for the truth, and when we find it, announcing it, talking about it, we devalue that coin, and we can never retrieve the value.
All right, well, we'll leave it there, but indeed, for all of us, it was very sad. John Holloman is a big loss. He was a friend. All right, we'll leave it right there for now. Now, our deep space probes, I hope I'm going down the right...
Absolutely.
I am.
Timing is impeccable.
Good. Tom, something is weird with our deep space probes. What's going on?
Well, I'm not sure. I haven't actually studied the space probe itself. I've been confining most of my work to energy and to some medical applications. And so I haven't looked at the probe itself. I do know that from the weaponry aspects, some very strange kinds of weapons are being used right now, which do affect the local potential of the space-time itself.
What?
So it may be that you're having some effect like that, but that's just a guess. I simply haven't looked at it.
Oh, Jehoshaphat. Well, we're going to come back to that one.
We will definitely come back to that. Let me try to give some context. I called you up and I sent this fax to you, which had been sent to me, by the way, by an old colleague of ours, Ken Johnston.
Yes,
former Boeing engineer, former test astronaut, who's been a member of Enterprise now for some years. In the very distinguished journal, mainstream science journal, The New Scientist, published in Britain,
right,
on September 12th, a remarkable article appeared. In fact, it's so remarkable that what we've done is have our ace webmaster, Keith Rowland, has got up on our website, at the top of the Enterprise mission website, accessible through the Art Bell website, a short link directly to the New Scientist gravity article I'm going to describe in a moment. So just go to artbell.com and you'll find my name, and you can go to Enterprise, or you can go to Enterprise directly at www.enterprisemission.com. At the very top of the home page, and now hear this, you will see a report on a NASA solar gravity anomaly, which appears to confirm, additionally, the hyperdimensional model. And there's a link directly to the New Scientist article.
Okay, but a NASA solar gravity anomaly.
That's right.
Break that one down to English.
Okay, for several years, an old friend of mine at JPL, John Anderson, who is, together with Tom Van Flandern, probably one of the preeminent celestial mechanics experts in the solar system.
Yes, sir.
John and I worked together with Jim Warwick back during the Voyager days on the anomalies found in Saturn's rings, and there was a whole little synergistic thing that the three or four of us did that resolved that there was something really wondrous and bizarre embedded in the main ring of Saturn found during the 1980 and 81 flybys by the Voyager spacecraft. At that time, John was beginning a project at JPL to track the outer solar system missions. We have sent now 2 Pioneer spacecraft beginning in the early 70s.
That's right.
2 Voyagers beginning in the mid-70s.
Right.
We've now got a Ulysses probe that went in the late 70s, early 80s. And we've got a Galileo mission that started in the 80s and wound up in 95 going into orbit around Jupiter. All these spacecraft are being tracked by means of radio signals.
Correct.
The way we know where they are is we, meaning science, has a general model. It's actually now called the JPL ephemeris for how gravity in the solar system behaves. And it applies to the sun, applies to every planet, every moon. It's basically how you navigate between Earth and Moon back when we used to go to Earth and Moon back during my Cronkite days.
Okay, now you're losing me a little. We know where the spacecraft is based on a model,
we have a model of how gravity works.
Does that? What are we saying here? That the various gravitational pulls of stars or planets or planets.
System. Exactly, it's the solar system and the bodies in it.
Should affect the spacecraft in a very known way at a known distance.
Down to, we're talking 8-9 decimals. All right?
Okay.
It's extraordinary precision.
All right.
And it's based on the theoretical model that comes out of Einstein with minor relativity corrections, and based on what's called radio tracking.
Okay.
The spacecraft is sending a signal back to Earth. That signal, depending upon how fast the spacecraft is moving, has a certain frequency.
Correct.
If it's moving away, the frequency is lower. The pitch is lowered. If it's moving toward you, the pitch gets higher.
So you have a constant Doppler effect.
You have a Doppler, right, a Doppler tracking. There's also what's called a range tracking. It's kind of like standing on the side of a canyon and going, hello, and then you hear a few seconds later, hello, hello, hello.
Right.
The echo.
Right.
So a spacecraft gets the signal. It doesn't reflect it. It basically regurgitates it. It absorbs it. It retransmits it with a time hack, with a time code.
Right.
So that the computers on the ground know when the signal that went from Earth got to the spacecraft and when it came back.
Right.
Based on those 2 tracking methods, we know where spacecraft are supposed to be all over the solar system.
And
there are dozens of spacecraft being tracked every single day by NASA's Deep Space Network.
I understand. So what's wrong?
Well, in this article, John and his colleagues report that for these 4 or 5 spacecraft that I named, the Pioneers and the Galileo and Ulysses,
yes,
they're apparently closer than they should be. Meaning
closer to us?
Closer to the sun. Well, us and the sun at that distance, we're talking billions of miles out there. we're so close to the sun that it's basically to us as well as the sun.
So you're saying they're not as far out as they should be?
They have not traveled as far as they should. They have been
Wow.
slowed down by some mysterious force, meaning
Wow.
in this article that the calculated model of the sun's gravity field is different than it should be. So, of course, this caught my attention because one of the key predictions of the hyperdimensional model is, guys, gravity, Earth, Moon, Mars, wherever, sun must change over time. It is not constant. So that's what I reported to you, and that's what I sent to you, and that's what Tom and I and Tom Van Flanner were discussing the other night. And tonight I have some new news.
Yes.
Because it is my contention, and Tom wants me to be qualified on this, so I'm going to be very scientific, and I'm going to follow your prescription, Tom.
Okay.
It is my contention that NASA may, in fact, be wrong. That there's nothing wrong with gravity. That, in fact, the gravity of the sun, instead of getting stronger, as this article implies, should be getting weaker. Now, why do I say that? Because if you go back to the paper that you talked about a few minutes ago on the web,
Yes.
there are experiments in laboratories all over the Earth indicating that G, the force of gravity between objects, is getting weaker. Now, Tom may have something to say on that in a few minutes.
By that, do you mean all gravity?
Well, the laboratories are here on Earth, all right? But the presumption would be in the model that if gravity on Earth is getting weaker, then gravity all over the solar system should be getting weaker. It's very hard to imagine in a natural model that the sun's gravity would get stronger and the Earth's gravity would get weaker.
And so you're saying if gravity universally, as we understand it, is becoming weaker, that would account for what's occurring to the spacecraft?
No. I'm saying that's the exact opposite. Here's the paradox. We've got good lab data saying that G is getting weaker.
Right.
We've got tracking by NASA of distant spacecraft saying it's getting stronger. There's a problem with this picture. It took me about a day to, I think, figure it out. And it's such a neat explanation. And when I run it past people like Ken and some others who are kind of involved in this, everybody has had the eureka experience. They've said, oh, my God.
Okay, so if I'm understanding correctly, our spacecraft are suddenly not as far out as they ought to be, meaning that the tug on them is stronger than it ought to be. It ought to be getting weaker as they get farther away from our sun.
On a predictable model, and it's not getting weaker as fast as it should. That's what NASA is thinking.
Okay.
So they're finding their spacecraft are closer to home.
I've got you, then thought.
All right. Well,
Okay.
I'm saying tonight that that interpretation may not be correct. And if it's not correct, it means that the hyperdimensional model is even in better shape than I imagined when I talked to you. Let me tell you what the answer to the puzzle is.
Sure.
The speed of light is changing.
What?
A key prediction of the hyperdimensional model is the speed of light is not constant. And Tom and I will talk in the next few minutes of a whole host of experiments, from laboratory experiments here to astronomical experiments that over the last century or so have proven that. In fact, there are websites I can point people to through our website where there are paper after paper after paper of historical changes in the speed of light, which just don't get reported by interesting coincidence.
Well,
radio waves travel supposedly at the same speed as light waves.
Yes.
Imagine this. If the radio waves are now, because the physics predicts it, traveling faster, in other words, our model says as G gets smaller, as the force of gravitation between objects apparently gets weaker, the speed of light will get greater.
Okay.
In proportion.
Meaning the speed of radio signal. Yes.
That's right.
I've got you.
Okay. Go back to my guy standing on the edge of the cliff, hollering hello, waiting for the echo. He knows that the speed of sound is a certain value, 1,000 feet per second. He expects, if he knows how far away the other side of the Grand Canyon is, that his echo will come back in a known number of seconds, right?
Right.
If it comes back earlier, he's going to assume that the canyon wall is closer than it was.
Correct.
But suppose the speed of sound has changed. We know that the speed of sound changes with temperature. If he doesn't factor in the change in the speed of sound, he will get an erroneous result. By the same factor, if the speed of light, the speed of radio waves traveling in the solar system is just a little bit greater than the textbook value now, what will happen is that the spacecraft will get the signal quicker than it should have. It will return it quicker than it should. Mm-hmm. The ground computers, assuming a fixed speed, will say, oh, it's got to be closer, and thereby the whole thing is resolved But it's not gravity getting stronger that's the solution. In fact, gravity, when you do the actual calculation, turns out to be getting weaker along with the lab data here on Earth. So the extraordinary anomaly that NASA is on record now as saying exists can have two interpretations, when all the other possibilities of unseen planets and plasmas and all the stuff that in the paper they eliminate as an easy answer is eliminated. And either answer is extraordinary, but the speed of light one is the one that is in conformance with our model, and that's the one that ultimately is going to be resolved. Now, where are we going with this?
Well,
NASA has another mission.
May I ask one question?
Absolutely.
We look at objects that are as far out as nearly 15 billion light years.
Presumably.
Now, what would be a small error in the distance you're talking about right now?
Absolutely.
At 15 billion light years out would be an incredibly gigantic error.
Well, the term astronomical error does seem appropriate.
Astronomical error. So,
you're thinking along the right track.
Am I?
Yeah, of course. Remember when we had this thing that blew up?
So then how would you apply this equation, if you work it out along the lines that you think you've got it worked out, to something as far out as 15 billion light years?
Well,
how much difference?
The problem is that you're not going to know unless you get baseline data. You can't send a signal now and get an echo back.
That's right.
In any human lifetime or 10,000 human lifetimes.
Would take 30 billion light years.
That's right. So what you need to do is to measure things where you know rotations and frequencies and see differences.
But couldn't it mean, Richard, that all our assumptions about distance are caca?
Absolutely. In fact, that's what I've said on several programs, that be careful that you don't interpret the redshift as a distance. The redshift can have another hyperdimensional explanation, which means that huge explosion that everybody was all gaga about a few weeks ago.
Yeah.
The event that was bigger than the Big Bang.
That's right.
I told you be careful because it could be one heck of a lot closer and therefore a heck of a lot weaker than Kaku and the standard guys were proposing. This new data from NASA, from our friendly local, I stress the local, neighborhood space agency, is moving us in the direction that the universe we think we know, we don't really know. Because years ago, a century ago, James Clerk Maxwell was suborned. They talk about suborning perjury. Well, poor Maxwell was suborned, and the laws of physics that we think we're operating under are not really the full set of the laws of physics.
All right. You've laid it out pretty well. We've not got a lot of time before the top of the hour, and I've not asked Tom very much. But, Tom, you're a nuclear engineer. When you listen to this well-done explanation of what Richard believes may be going on, how does it set with you?
Well, it sets pretty good. I would phrase it a little different. For example, when we're talking about the gravitational pull, we're actually talking about the creation of a force on an object, gravitational force in this case. And from a general relativity viewpoint, what you're talking about is a change in the curvature of space-time. The curvature of space-time, a little curvature generates a force. Mass or trapped energy curves space-time. The curvature of space-time reacts back upon the mass to produce a force. General relativity is based on the fact that space-time itself, or curvatures in it, are active back upon mass. And so when we're talking about something is happening to a spaceship, there's a local effect on that ship. Now, we can say the whole sun has decreased or increased or changed its gravitational attraction.
That may be. Tom, hold on. We've got a break here at the top of the hour. We'll be right back and talk more about what's happening to our deep space probes. Once again, here I am. Good morning, everybody. Great to be here, and I mean that. Tom Bearden is here. He's a nuclear engineer, along with Richard C. Hoagland. We just found out something rather interesting. Our deep probe spacecraft are not acting as they should, meaning they're not as far away as NASA thought they were. Now, why would that be? A change in gravity? Or, as Richard suggests, consistent with hyperdimensional physics, a change in the speed of light. Radio waves, light, similar. Actually getting faster? That's what we're being told. This will be presented to some degree in the theoretical, but you need to read between the lines. Tom Bearden is a retired Army colonel who was involved in some pretty interesting projects, some of which he can't talk about in a very direct way. So you're going to have to read a little bit between the lines as you listen to some of what you're about to hear. Apparently, Richard C. Hoagland and Lieutenant Colonel Thomas Bearden, with whom we're talking at the moment, as well as astronomer Tom Van Flanderen, are going to be appearing in Seattle, I guess, and they're running some commercials up there that might say the wrong thing. Apparently, tickets are going to be available at the door, and that's what's supposed to be said on the commercial, and I've got news that it is somehow wrong or something. So when is this thing you're doing, Richard?
It's Saturday and Sunday, the 26th and 27th, and it's the first time that the three of us have done anything in public. It's a two-day conference, and it's going to explore not only the dimensions of the hyperdimensional physics and some of the things that Tom is going to talk about tonight in much greater detail, but it's also going to bring Tom Van Flanderen together with Tom Bearden.
Right.
Because, of course, Van Flanderen is looking at planets which, for some reason, go bang in the prehistory of the solar system, and the energy sources that we're talking about, the hyperdimensional model, certainly is more than adequate to blow planets apart. And what has happened, of course, is as a result, if you even don't go along with Tom Van Flanderen, we have what's called an asteroid and or meteor problem. And in fact, this November, per a fax I sent
All right, but you're drifting on me.
Well, all right, what we're going to talk about is the application of this physics and this technology.
Yeah, where is this, Richard?
It's going to be at the Seattle Center.
Thank you.
In Seattle, from 10 a.m. to 5 p.m.
10 to 5
on Saturday.
Okay.
From 10 a.m. to 5 p.m. on Sunday. And from 7 p.m. to 10 p.m. on Saturday night, we're having a roundtable, kind of like a town meeting. And the tickets are available. There is a phone number I can give you, which is 360-491-3714.
All right, but there's a big thing apparently about tickets also available at the door.
And they will be available at the door.
All right, good. I wanted to get that in. I got a little fax here saying this is the act of a desperate woman. They're running the wrong spot.
Uh-oh.
So tickets available at the door. There you go. So I feel I've done my duty now.
Thank you, Tom. Thank you.
All right, now, we were talking about the speed of light actually increasing as one explanation for what is wrong with our deep probe spacecraft, and not only spacecraft, but you're suggesting other astronomical objects as well, like meteors or asteroids or whatever.
Well, there is a mission. There is another mission which NASA has out there going toward rendezvous in January of 1999, and we discussed this maybe 2 years ago. It's called the NEAR mission, for Near Earth Asteroid Rendezvous.
Right.
Spacecraft was launched, a couple of years ago, and goes through a long looping trajectory to get to where it's going to go, because it had to make a plane change. It rendezvous in January and goes into orbit around this little 15 or 20-mile sliver of rock called Eros, which is tumbling through space and is on a very elongated orbit that takes it around the sun every few years. Now, it turns out that Eros is probably the most tracked asteroid in astronomical history, and it used to form the basis of the scale of the solar system. As it went by the Earth and through the inner solar system every few years, astronomers in the last century and in the early parts of this century would take pictures from different observatories and record the time. And through good old trigonometric parallax, in other words, the width of the Earth, they would get a different direction slightly in space for two photographs taken of the asteroid at the same moment by celestial time.
Right.
They would then compare those differences on the photographic plates, and with good old trigonometry, they would establish how far Eros was from the telescopes, from the Earth. By using Kepler's third law, they then could map out its trajectory through the whole inner solar system and thereby derive the scale. Back when radar was first developed and NASA started bouncing radar beams off planets, they found a very weird anomaly. The radar results did not match the Eros results. Venus appeared to be closer or farther away. Mars appeared to be closer or farther away. it was topsy-turvy, and so there became a kind of like an edict came down, and the speed of light and its arbitrary limit at a fixed velocity was assumed by all future NASA experiments to be the wisdom, the way the physics worked. And the Eros data from hundreds of years, literally 100 years or so, was thrown out. Now NASA suddenly launches a mission to one asteroid in the whole panoply of 40,000 that are known that has this tremendous historical database. And they're claiming publicly that they're going to just look at this asteroid. Well, privately, I know there's a hidden agenda. And I know from the science that what they're really doing, some of the experimenters, is when they put this little thing in orbit around Eros and track it, they're going to be monitoring the radio beacons from the spacecraft while they simultaneously take good old-fashioned photographic plates of the trajectory.
Can I ask a layman's question?
Sure.
You remember that big panic they had about an object that was going to hit Earth in, 20-something or another?
Yeah, the comet Swift-Tuttle in 2161, yeah.
Right, okay.
Announced by Brian Marsden at Harvard.
Yeah, and everybody went into a great panic, and the day after they said, no, we're wrong.
Yep.
Well, if you're right, could they be wrong?
Yes.
Uh-oh.
See, this is where the rubber meets the road. This is why Tom is on the show tonight, because what Tom's going to talk about is the engineering, literally, of reality, using this hyperdimensional physics and the fact that there's an in-crowd and an out-crowd, and the in-crowd is knowing it and using it, and the out-crowd doesn't know it even exists. And the problem is the out-crowd is in control of our public policy, like trying to keep our satellites in orbit in November when the Leonid meteor shower is going to smash about 20% of them, according to NORAD.
That's really important. Tom, being a nuclear engineer, though it's not exactly your field, if Richard is right about what we've discussed thus far, could they be wrong about this comet missing us by that amount? Would you agree with that?
I would have to say that, what conclusion you draw depends on what kind of model you apply. Richard has, I think, very accurately stated that.
Yes, if we're applying Richard's model, could they be...
you get a different answer from what they have. And right now, what they really would say is, well, our model has applied, but now we have cases where suddenly it doesn't fit. It doesn't fit what's happening to the spacecraft. It doesn't fit what's happening in some of the experiments, at least on Earth itself. And as Richard said, there's a very interesting thing about the two sets of data taken together. There are two ways you can have a gravitational change. I'm using gravitational in the general relativity sense of just curvature of space-time. You can have a global effect, that is, the sun could change its gravitational effects, the strength of it, for example. Let's say it changed the strength of its gravitational field. Well, this wouldn't affect just the spacecraft out there. This would affect all the planets and everything else. I mean, you would have a probably very appreciable results of that clearly seeable in the solar system on the other planets.
Tom, let me stop you there, because the reason that John Anderson at JPL started tracking these spacecraft is because of exactly that effect. There is well known in the astronomical literature, going back a couple of hundred years, after Uranus and Neptune were first found, and Pluto was found,
themselves,
that those planets themselves are not behaving according to the current laws of physics. Now, for Uranus, that anomaly was used to predict where Neptune would be found, and lo and behold, it was found pretty close.
Yeah.
And for Neptune, the anomaly was used to predict where Pluto should be found, and lo and behold, Percival Lowell found, Clyde Tombaugh found Pluto in 1930, but now we know it was a wonderful accident because the planet's too small to cause the effect on Neptune that was in the literature. So Anderson started tracking these spacecraft over long, decades now, with very high precision radio tracking in an effort to find out whether these anomalies were due to unseen planets way out there, or, by his own admission, whether the gravity model is wrong. And he now has come to the conclusion that the gravity model is wrong. Well, this is not trivial. This is big, huge, headline-grabbing stuff.
I agree.
Because it means, back to Art, that when they confidently say, as Don Yeoman says, it's going to miss us by 600,000 miles in 2161, No, they can't be that damn confident because the model is wrong.
Well, let's put it this way. I would say the model results are wrong because it doesn't agree with what's being observed. Now, I'm not just splitting hairs.
Results.
There's a thing I'm trying to get at here. I'm not just splitting hairs.
Okay, go ahead.
The gravitational effect, whether it's global, local, or whatever, is going to be involved with a curvature of space-time. The gravity does that. That's the whole basis of the interaction of gravitation and mass in the general relativity theory. So what we're saying is that we have some effects, however, which tend to refute one another. One says, well, it's getting stronger if I'm looking at it as a global effect, and the other says, no, it's really getting weaker in what we measure on the surface of the Earth.
Yep.
So I think you very accurately pointed out that we do have a contradiction here. Now, what a contradiction usually involves is that something in your model is wrong, or some other factor has entered that you're not taking into account at all. You're just assuming it's in my normal model that I use and nothing else has intervened. You have one of two things occurring. I'm just, taking the problem as it occurs. You have either something extremely dramatic happening and your model is now completely off base, or you have the intervention of an outside factor that you're not taking into account. In other words, missing variables. So one of the two they have to have wrong.
Let me stop you there. One of the things that Anderson and his guys they are very good. They're world class, as Perot used to say, all right? In their paper, which, by the way, is also linked to the New Scientist article in Physics Review Letters, they talk about all the possibilities which could give us a synthetic anomaly. In other words, an error that isn't really there, like
except one. They missed one.
Huh?
They missed one big one.
Okay. Well, they went through all the ones they thought of.
Yeah, the ones that they know about, they listed.
That's right. So when you eliminate, as Sherlock Holmes used to say, when you eliminate the possible, you have to go for the impossible.
That's correct. What I would characterize, I try to characterize that a little bit more exactly, you see. What I would characterize is, say, the factors that they considered. I would put that phrase in there, because if they're factors they didn't consider, then it means that they didn't consider the outside intervention at all, except what they knew about. If it's something else, it was something they didn't know about.
Let me be clear. Everybody's walking around this one. You said they missed one big one, Tom.
Yes, they did.
What did they miss?
Okay. Part of the thing that Richard pointed out, there's some terrible problems in electrodynamics. First of all, when Maxwell put together his theory, everybody believed in a material ether. There was no question about it. Space was considered by all parties to be filled with so-called luminiferous ether, a thin material filling all space. And electrodynamics today, in spite of anything anybody tells you, every university in the Western world is teaching electrodynamics where the material ether is still present in the equations. They still assume that at every point in space there is a unit north pole, and that's a magnetic charge mass.
Right.
There is a unit positive electrical charge, a coulomb, and that has some mass, and there's a unit mass, a kilogram of mass at that point in space. And those equations describe how that point mass reacts.
And they assume that's a universal law.
Yes, and you see the Michelson-Morley experiment destroyed all those point coulombs and all those point unit masses and so forth, but they never changed an equation, not a single one. So what we're teaching still assumes the material ether in every university. It's present in the field concept. The idea of a force field, a force contains mass. It's ddt of mv, so you have mass present to have a force. That's well known in foundations physics. People like Feynman and Wheeler tried to correct it for that. They failed, but they had a magnificent try at it to get rid of that field concept in space, because force fields do not exist in space. And since 59, I think the physics community understands it, but as Feynman said, it's so useful, we keep using it. We have some very flawed models. Richard is very much within the ball game there when he's saying that the models have some serious errors in them. They indeed do. If you have errors in fundamental electrodynamics, which you do, terrible errors, then that permeates everything you're doing, because they just spread the electrodynamics into all the other systems.
Well, all right. If I understand all we're talking about correctly, Richard, question for you. They find a quasar, which they declare to be at 15 billion light years out. How far off could that be?
Oh, it could be thousands of percent.
Thousands of percent?
Because of exactly what you said half an hour ago. A little bitty error in the solar system propagates to astronomical errors at astronomical distances. And well, I'm not the only one saying this. I mean, this is a whole alternative cosmology.
A lot of people are sitting out there right now who are creationists who are saying, right on, Richard. Do you realize the allies that you just picked up?
Well, okay, but they may not be right either. The point is, in science, you keep an open mind. You look for evidence and data and trend curves and predictions, and you're ready to revise at a moment's notice on the basis of new information. We've got new information.
Yeah, you're right. That's science. That's real science. Hold on, you two, and we'll be right back. We're about to talk about now dive into kind of a sensitive area with Tom Bearden and Richard C. Hoagland. Tom, I know that you know something about weapons systems. You've done some work in that area. What can you tell us theoretically, or even from a science fiction perspective, which people can read in between the lines of, about what might be possible if what Richard says is correct?
Well, what's possible is, first of all, you get several different new things in electrodynamics. And by the way, part of this, you can go on the Los Alamos National Laboratory website, download a paper, for example, by Rodriguez and Liu, and several other papers, and they will give you a summary of some of the new work in electrodynamics that shows the use of longitudinal waves rather than the conventional old transverse waves. Now, when you use longitudinal waves, you get some extraordinary capabilities. One of the things you get, a pure longitudinal wave, if you could make one pure, normally if you make one, you make it with some residual, some noise hanging on it that's transverse stuff. It has some, it's a messy signal. But if you can make a pure one, it goes at infinite velocity and has infinite energy. So, of course, they don't make that, but they make waves that go faster than the speed of light, and they make waves which don't have the proper energy that you would predict from the normal electrodynamics we all were taught. For example, NIMPS and colleagues transmitted with quantum tunneling and through a barrier and a waveguide, they transmitted Mozart's 40th Symphony at something like 4.7 times the speed of light. So we need to, first of all, get completely out of our minds the idea that the old idea that's been so ingrained that the speed of light is an absolute limit. It is not. It depends on what else you're using. If you use longitudinal waves, the speed of light suddenly becomes, quite variable, if you mean the speed of the wave that you produce. So you already have a new physics the moment you go into the use of these longitudinal waves. Well, several nations of the Earth, and the most predominant one is done under the auspices of what used to be called the KGB, and I'll still use that term because the leopard did not change its spots.
That's right.
Is done in Russia, but under the rigid control of the KGB. Now, they've been doing this for decades, and they've highly weaponized it.
Doing what?
Making longitudinal wave electromagnetic weapons.
Let me, Tom, let me stop you there.
No, let me stop both of you. I interviewed.
You need to define these waves.
I interviewed the top rank military defector from the Soviet Union, the biggest, highest ranking defector in the history of defections from the Soviet Union, and he said there is. In fact, he named the program. That there is a program the Russians have been working on for some time now involving waves of the kind you're talking about that produce seismic events on Earth, seismic weapons.
And
well, they've had those for years.
I'm sorry?
And
they've had those for years.
Okay, you're both doubling here, one at a time. Tom?
They have had that weapon for years and years.
That's what he said.
They have, yes. They've had lots more. That's just one of the small ones.
And weather modification.
They've been doing weather modification. The first weather modification they did over North America was in 1967. The signature was perfectly round holes appearing in clouds, and they gave us the anomalous winter we had, that very rigorous winter we had that year. They opened up full-time weather engineering over North America, and then spread to much of the rest of the world. On July the 4th, 1976, that was their bicentennial gift to the U.S. They have a sense of humor.
Yeah.
A crazy one.
Tom, hang on a second. All right, remember when Russia offered to put out the fires in Indonesia, and they offered to do it by creating monsoons?
A cyclone, yes.
Cyclones?
Yes, yes.
It's this physics and technology.
They said they had the technology to do it now. I mean, there was no question about it. They were simply seeking permission to go ahead and test it, create a cyclone, and put out the fires.
This was, in fact, part of the geopolitics going on behind the scenes, because it's kind of like showing your cards to the other guy who knows you've got them, but now you're showing them to the rest of the world, and, of course, controlling the weather makes nuclear weapons look like matchsticks.
Oh, yeah.
Well, in 1975, some of these weapons were so frightful that even the Russians got frightened. Brezhnev called them, he used the phrase, more frightful than the mind of man had ever imagined. And he actually had Gromyko in that year introduced to the United Nations a draft treaty to stop the production of new weapons of mass destruction again. You know, he used that phrase. And what he was referring to was these waves and these kinds of weapons using longitudinal waves.
Are these what other people call scalar waves?
Well, exactly. A scalar wave is a little bit different kind of critter, but you start with longitudinal waves to get it. A scalar potential, common old voltage in electromagnetics, if we go back to Whittaker in 1903 and 4, we find out that it's made of longitudinal waves.
First of all, I don't understand what longitudinal waves are.
Okay, let me explain that then exactly. And I'll do it simply. If I'm moving along in a straight line and I want to vibrate, there's several modes that I can vibrate in. I can vibrate left or right, and we might call that the Y direction.
Okay.
I can, or X direction, let's say. I can vibrate vertically, and we would call that the Y direction.
Okay.
Up and down.
Yep.
And then I could be a crazy fool, and I could rush forward a little bit faster, and then a little bit slower, and a little bit faster, and a little bit slower. I could velocity modulate. I could keep changing my velocity surge back and forth as I went along.
Sure.
And that would be a longitudinal wave.
Sound waves.
It's like a sound wave, exactly like a sound wave.
How do you get a weapons application here?
Well, it's real easy. Whittaker in 1904 showed us that all the other stuff's made from these longitudinal waves and their interferometry. That scalar potentials make the whole thing. That paper, by the way, sparked a thing that's a little obscure, but it is well known in cavity theory and so forth, waveguides, called superpotential theory. And so he showed that we can do away with all the waves and all that stuff and replace it all with potential functions anyway.
Now, those two papers, those two key Whittaker papers, for any physicists listening tonight, are attached to my paper on the web through Art Bell site and Enterprise. You just click on them. They're underlined. You go right to Whittaker, and there you are. The full Whittaker papers, Tom. And Maxwell's original 900-page treatise, I've been informed from my folks tonight, is about halfway through the copying.
Good.
And by next week, we should be able to post it on the web in its original, pristine 1873 first edition.
Good.
Including the 20 quaternions, which describe the hyperdimensional physics originally that we're discussing tonight.
Well, what happened is, if you use the longitudinal, basically, to put it real simply, if you make longitudinal waves, which you can make with plasmas and some other things, plasma gas tubes and so forth. There are several processes you can use to do this. And then if you interfere these longitudinal waves, in that interference zone where they meet and conflict with each other, you produce ordinary stuff, the ordinary stuff we talk about. The transverse waves, you can make it either cold or hot. You can make heat energy or you can make cooling energy. You make it diverge, which is heat, or you make it converge, go the other way, which is cooling. And you can do that at a distance.
Tom, let me stop you. Art, remember El Nino?
Yeah, of course.
Remember the warming all around the Pacific and around the Galapagos?
Yes, sir.
And remember the sudden, incredibly cool waters that miraculously appeared in just days? And the cool waters in the Gulf of Mexico that you reported on this show?
Virtually devoid of life, yes.
Those are indicative of some kind of technological application of the kind of wave hyperdimensional technology that Tom is talking about.
No kidding.
And it gets better. Longitudinal waves don't interact a great deal with mass. They interact fairly weakly, but they do interact. But because they interact so weakly, they'll go great distances through mass. In other words, you can pass longitudinal waves right through the ocean, right through the Earth. And you can interfere them on the other side.
So, Tom, let me be clear. You're saying the Russians are, and for a long time, have been doing this?
Yes, they deployed the first major weapons, not the first research test, but the first major weapon was deployed in April 1963. And the first test they used was to kill the USS Thresher, atomic submarine, underneath the water off the east coast of the United States.
What?
They killed the Thresher, and one day later they put a huge burst underneath the water 100 miles north of Puerto Rico. That burst was sighted by the crew and folks on board one of our jet airliners and was reported to the FBI and the Coast Guard. You had a cone of water rise up about a half a mile high, turn into a mushroom, and fall back into the water.
Oh.
It was one test one day to kill the latest attack submarine we had. Second, the next day was to show what you could do as a giant burst underneath the water. What they do to engineer the weather is very simple. What you do is you pick a place and you create a little hotter air. You create a thinner air, which means the air expands and gives you a low pressure. What the footprint on the ground is a low pressure. You create a low area. Then you cool it in another area and you create denser air, which weighs more per cubic centimeter and has a greater pressure on the ground. So we would call that a high pressure area. And by doing this and then steering that place you're heating and the place you're cooling, by steering the hot spots and the cold spots, you can actually entrain the jet streams and steer them. So what they really do is they steer the weather.
God, Tom, your background is that of having been a colonel.
Lieutenant colonel, yes, retired.
Retired lieutenant colonel.
Got to use that word retired now. I
understand that, but I'm bound to ask you, what you just said is so provocative that I've got to ask you whether you know this, from firsthand information.
I would rather not answer that question. What I will answer is the fact that I'm very sure about what I'm talking about in the Soviet Union and three other countries, one of which is not us, by the way. Wish it were.
But one of which is us. In other words...
No, one of which is not us.
Are we not doing these things, Tom?
Well, I would rather not even address that issue.
Okay.
But what I would rather talk about is the fact that the Russians have them for sure, and we had better get with it. If your other guy's got a sword and a shield, you ought to at least look around for a long knife.
Yeah, I hear you.
So the point is the weapons do exist, and they've been used. We haven't had normal weather over North America since July the 4th, 1976. We're not going to have it again. By the way, to touch up what Richard was talking about, since you can put the things under the water, instead of having a big burst, instead of pulsing your weapons, what you do is you just put the beams to cross and gradually heat the water if you want to heat it, or you gradually cool it if you want to cool it. So you can touch up both El Nino and La Nina, both of the major things in heating and cooling the water that do wind up having large-scale effects on the weather. So that's another little trick you can do. If you put the energy and start to create the energy inside a fault zone, for example, as the energy builds up, the rocks are piezoelectric, so they expand mechanically as you put more energy into them, and so gradually the rocks will then slip and you'll have an earthquake. If you really get desperate and you need an earthquake real bad, you just pulse the energy and put it in the rock whether there's a fault zone or not, and it'll blast its way in there.
Now, this
the earthquake weapon follows straight forward. Once you can do longitudinal wave interferometry, you can do that at a distance into the Earth or through the Earth or in the ocean.
Now, later in the morning, probably in the next hour, we're going to talk about some real environmental threats that we're going to experience for the next couple of months. The Leonid meteor shower.
Yes.
And the NORAD alert that 20% of the 500 satellites we depend on for our life and our economy and our almost existence now are going to go down. They're going to be killed. by little tiny flecks of dust moving at 30, 40, 50 miles per second.
I guess 1998 and 99 are due to be
You got it.
The big years, huh?
November 17th. I mean, we're looking at a major global economic meltdown if 20% of the satellites get killed upstairs.
Is that really likely to occur?
That's what the NORAD numbers are, and that's what the ABWEEK numbers are, and that's what the quiet discussions are behind the scenes.
You know, it's not just NORAD, but what about the satellites that carry my voice? I mean, we've got Y2K, and if that doesn't get them, the meteor shower will.
Well, I am looking at a chart here provided by one of my cable people tonight. It turns out that two satellites, and I'm going to give you the names of them, okay? Two satellites, it's here in my pile. I know I had it in my pile a moment ago. Two satellites carry most of the television traffic, all right?
Oh, yeah, Galaxy 5.
They are G5
Yep.
and C4
Yep.
carry half of about 24 of the contemporary cable channels.
Correct.
If we lose two satellites, America goes dark.
You know how
we lose CNN.
Do you know?
And this is another point. There's no transponder space, so we can't see it and can't move to some of the satellites.
I know, Richard. You know where I am right now?
Yeah.
G5.
Oh, great.
That's how your voice is getting to the people. G5.
Well, it won't pass November 17th unless something is done. Now, this comes back to what Tom just said. In the black world, in multinational laboratories, there have been developed some extraordinary hyperdimensional weapons / tools, which if they came out of the black world and were applied to the white world, to saving our asses in November, we would basically get through unscathed. And what we wanted to do tonight was to let people know that this is not theory, this is real physics, real technology, and a real problem that needs to have this applied to in the not-too-distant future.
Yeah, but look, if the Russians have the power to destroy a submarine beneath the sea, if the Russians have the power to change the weather, and they've been doing this, and Tom just confirms that sort of almost in an offhand way,
well, that's the first and
how in God's name can we not know about it?
Well, when you say we, who's we, Kimasabi?
Well, we is the general public.
We normal Americans who pay our taxes and elect presidents who don't run things, admitted by various intelligence people now. You don't inform the president.
Yeah, but look, to most people, this is Buck Rogers, period. It's not real. It can't be real. To the average American, would more easily believe the President of the United States right now than he would that the Russians can do these kinds of things. Are you sure?
How could the Russians have offered to create for Singapore cyclones on demand?
Well, I'm amazed at that. I looked at that in the news and I said, what the hell? And I talked about that for 2 weeks. And it and it never hit the mainstream press. But it was a real report.
Mark, let me give you an incident that might shed a little light on it. Some years ago, I put in a publication that you could cool things. You know, you could cool materials and all kinds of things at a distance. Mm-hmm. I was called every kind of nut for saying that you could do that, and you could also dissolve materials, turn them into liquids and so forth. I was considered in the intelligence community, I was considered your local real nut.
Yes.
Well, some years after that, that wasn't the last end of that story. Some years after that, working with a aerospace firm, foreign aerospace firm, which must remain nameless, I furnished them an address that appeared on the internet for some Soviet scientists who were scrambling, trying to find something to make a living and set up a company and so forth.
Got to do this quick. We're coming to the top of the hour.
Okay, so to make a long story short, they sent in an engineer very fluent in Russian, and these Russian scientists showed him what's called cold molding. You could put this scalar charge on the piece of metal. The metal would turn liquid at room temperature without heating. You simply dissolve the lattice bonds. All you do is phase conjugate them. That's what you do technically.
Phase conjugate.
But they turn it into a liquid at room temperature without heating. Pour it in a mold, walk away, let the charge die away after a while, then it turns back into a normal metal. So they could use this to mold the metal without heating.
That's incredible. All right, everybody, hold tight right where you are. Oh, my. I'm Art Bell, and this is Coast to Coast AM. Back now to Richard C. Hoagland and Tom Bearden. Richard, I guess with you, to begin, this meteor shower coming in November. I have in front of me the warning you sent, but repeat it for the audience. How serious is this going to be?
Every 33 years, give or take a month or two, the Earth passes through a meteor stream caused by a comet called Tuttle, where we basically really get an incredible show. The last time the Earth did this was in 1966, and I have reports from a group of amateur astronomers. All of North America was clouded out that night, so only the western part could even have seen it because it was dark out here. And except for Kitt Peak, the west coast was pretty socked in, but a group of astronomers on Kitt Peak, which is in Arizona, just southwest of Tucson, at about 6,000 feet, were watching, and as the evening built toward the expected climax, the meteors that they saw eventually covered the entire sky. There were over 150,000 meteor trails per hour. That's over 40 per second. And there was nothing upstairs. I mean, you are literally guarded from this, incredible, spectacular light show by the Earth's atmosphere, because we're talking about very tiny stuff, flecks of sand or micron-sized stuff. There, in fact, is in John Lewis's book. John Lewis is the current, he's a NASA guy. He's the co-director of the NASA University of Arizona Space Engineering Research Center. He was at MIT. He's one of the key theorists on the formation of the solar system. He wrote a book a couple of years ago called Reign of Iron and Ice, the very real threat of comet and asteroid bombardment. And I want to quote to you a couple things from the book. He has a quote in here from a tutor at Yale who witnessed the 1833 Leonid storm. These are called meteor storms, and was so impressed that he wrote this rather remarkable observation in 1834 in the American Journal of Science, and I quote, his name is Alexander Twining, who wrote this: "The multitude of bodies was such as no man can venture with confidence to limit by numbers." This is 19th century prose.
Yes.
"And had they held on their course unabated for 3 seconds longer, half a continent must, to all appearances, have been involved in unheard-of calamity. But that almighty being who made the world and knew its dangers gave it also its armature, endowing the atmospheric medium around it with protecting no less than the life-sustaining properties, and considered as one of the rare and wonderful displays of the Creator's persevering care, as well as the terrible magnitude and powers of his agencies, it is not meet that such occurrences as those of November 13th should leave no more solid and permanent effect upon the mind than the impression of a splendid scene." And John goes on to say, "Such sentiments are rarely encountered in scientific journals of the late 20th century. It is by no means obvious to me that this development is an improvement." The point is that for the terrestrial bound, I mean, you're planning to take your show outside under glass.
You bet I will.
In November and do the show out. Well, you may do it for a little while, but one of those little bullets at 70 kilometers per second could take out Galaxy 5, and suddenly we're no more.
Good night, Charlotte. Well,
exactly.
It's actually more serious than that. We have further satellites we depend on, KU band links. Those are other satellites also in geosynchronous orbit, and they would be as well threatened. So if one doesn't get us, the other will.
Okay, to cross this meteor stream, which is basically in the orbit of this Tuttle comet, which we encounter every 33 years, the dense core, takes from 2 to 6 hours. That's about, at the Earth's motion around the sun of 66,000 miles per hour, that's about 300 to 400,000 miles, slightly twice the distance from here to the moon.
Okay.
In that space of time, we will encounter literally millions upon millions of little speeding bullets moving through, tens of kilometers of space very close together. And those bullets are now going to impact on some of the 500-plus satellites in geosynchronous orbit, which are the literal life's blood of modern 20th century civilization. In the current arsenal, Tom and Art, there is nothing to prevent this act of God. We are naked. What Tom and I are here tonight to report, me from the theoretical side, and Tom from his observations and military background is there are folks with black technologies based on this hyperdimensional physics and technology that wish that we could get them into the open and get them to apply these weapons to basically carve a path through the Leonid stream. We could emerge unscathed on the other side on the morning of November 18th.
You're saying they could literally shoot a beam into space ahead of Earth and blast a hole through the oncoming...
Well, what you actually do is you'd focus several beams, these longitudinal waves, and you create scalar effects at that location in space. And you could literally vaporize or move the particles or create synthetic gravity and clear a path. That's one of the ways to do it, and you wouldn't have to send anybody out into space.
Tom, is that really, in your opinion, possible?
Yes, the 1904 paper, the thing that started superpotential theory, if you have the longitudinal wave technology where you can make them easily and already, you have to do that to have the weapons anyway, you could, in fact, create forces of your own intent on those particles. You could just take a region in space, and in that space, any particle of mass that entered it would have the forces appear on it. That's doable.
Like a huge vacuum cleaner.
All right, but you
just push the particles aside, like a plow going through the ground.
Okay, but in doing so, you would reveal the...
Well, you'd reveal that you had the longitudinal waves, and obviously you'd weaponize them.
Well, wait a minute. You wouldn't have to, because you see, space science is kind of unpredictable. And I talked to Tom Bearden, who, of course, is one of our celestial mechanics experts. He and Don Yeomans at JPL are having this interesting little food fight, because Tom is thinking that the severe part of the storm will be this year, and Yeomans is saying it's going to be next year, November 99. It's kind of like comets. Remember how many comets that come around the sun, Art, that kind of have fizzled?
Yeah. Oh, yes.
Done what they were predicted?
And or done better than predicted.
That's right. Well, if we were to arrive at the Leonid stream on November 17th at 1900 Zulu, which is when it's supposed to peak, that's Greenwich time.
What is that in Pacific time, do you
I was trying to figure it out this afternoon. I think it's around 10 o'clock in the morning here. I think. But don't hold me to that, because it's late at night and I was not feeling well today, so I'll recalculate that. 1900 Zulu. Somebody will fax in or whatever.
No doubt.
The whole point is that if we get there and nothing much happens, it's the most incredible case of plausible deniability. Because these beams, this technology never has to be made visible. Nobody has to stand up and say, we did it. It's just that nothing disastrous happens to the satellites, which means nothing disastrous happens to the world global economy, and we don't plunge this planet into an incredible depression from which there may be no bottom. That's what the prospect is, because everything from commercial television to you, to banking, to credit transfers, to, I mean, everything is going through the news sphere.
I know. Look, a Galaxy 4 went down, and
look at the havoc.
I know.
One little satellite.
I know. Oh, no, you're exactly correct. But they would then have to reveal publicly, I would think. No, you're saying they wouldn't. They would just
what will happen is it just won't be as spectacular.
All right. Well, then how do they explain to the astounded astronomers in 98 or 99 why it didn't happen?
Because the errors are sufficiently large that they could get away with plausible deniability. Well, we didn't go through the heart of the stream. We went past the edge. The precessional effects on the orbit of the Leonids was a little greater or worse than we calculated. Or they could fall back on the neat new one we've given them tonight. If the solar gravity field is different, and their modeling calculations are not worth you-know-what.
Tom, do you think there's any chance they will use this technology for such a purpose, or are we instead going to blow up submarines under the ocean and change and screw up our weather?
Well, one of the things I've been very hopeful of is that enough of this stuff will bleed out, that our own scientific community will start to really pay attention, which they finally started doing. The fact that Los Alamos National Laboratory is carrying a whole series of papers dealing with longitudinal waves, and the ones that are imperfect, they call them undistorted progressive waves, and their characteristic is really revolutionary. So I'm delighted that they're doing that. Now, if they'll really take that seriously and go ahead and apply it, you don't have to build weapons with everything. Okay, let the weaponeers do the weapons. Meanwhile, it has tremendous applications in things like energy and medicine, and things that can do a lot of benefit for people. And certainly if you can clear a hole through a meteor shower or little particles that are going to do you a lot of damage to your satellites, that would be a very useful thing to do. I would like to see them do it. Either us develop the stuff and do it, or, the Soviets or the Russians who already have it, do it anyway.
You see, this falls under absolutely squarely, and probably for the first time in many, many, many years, of a real good solid case for national security. Because if tomorrow, let's say Clinton were to get on television and say, we've discovered a terrorist group that's going to take out 20% of our satellites, don't you think Americans would get a little pissed that we didn't do anything about it?
Well, yes, absolutely.
And what Tom and I are saying emphatically is this is not theory. This technology exists. There are examples over and over again of it's being used in the past several decades. It's just so deep in the deep black that those guys have to be dragged kicking and screaming to even use it for a purpose like this, because they would rather keep it secret. Secrecy in this game is power. And in this case, there is a way they could use it and never reveal that it exists, and ultimately everybody would breathe a huge sigh of relief, and then we could get on with life that is important.
Now that I've had, I'm still, I'm stuck way back on, the Russians blew up the Thresher. I'm stuck back on explosions underwater creating virtual mushroom clouds above water. The whole scalar wave.
They've been doing that for decades.
Yeah, I know. Well, I'm still stuck back there. They've been doing that for decades.
Art, do you remember a gentleman named Nikola Tesla?
I do.
Nikola Tesla's technology was the same technology we're discussing tonight. Nikola Tesla was the first modern technologist to discover the so-called column or standing wave, which is nothing other than Tom's longitudinal wave.
Well, what's more important, hiding this technology from the public or averting a meteor shower that might take Art Bell and HBO off the air?
Well, it's even much more serious, because if all of the world goes dark television-wise, your wired world disappears.
I hear you.
I have talked to cable people in the last few days, and they're telling me that when I was running Enterprise in Washington, where the name came from, was this school experiment that we gave to Dunbar Senior High on Capitol Hill. NASA Goddard came over and gave the kids a satellite system and a dish and engineers, and they set it up and all that. And I used to tune through the bands and found that there was a tremendous oversubscription. We had satellites in orbit that literally had just dark transponders or bars 24 hours a day. That no longer exists. The pricing for a transponder used to be $400 an hour. Now it's over $1,000, because, like anything, if something is scarce, people can get more money for it. So if you lose 20% of the satellites, there's no place for those customers to go. CNN has no other satellite it can beg, borrow, or steal. And the replacement rate, if you want to launch from the ground new satellites, takes a year or two to build and to launch, and you have to build the launch vehicles, and they're backed up on orders for that. So we're talking about a major economic global meltdown of people basically being kicked back not to the 20th century, but to the 19th century in many cases, because so much of our high technology now depends critically on what goes through space over our heads.
How do we out all of this publicly? I mean, we're doing this now. What else can be done?
Well, that's one of the things this conference on the weekend is going to do. I brought together Tom and Tom. I couldn't find Harry, so we'll have to do with, Tom and Dick. So we can lay out the problems and the options and the physics. It is time that this technology went from the black to the white, that the Cold War is over in most cases, and in much of this, the major hold on it is the secrecy itself. That's what Francis Barwood was running against.
I know.
Too much secrecy run amok. Stephen Greer and I have been in very close consultation in the last few weeks. On Friday night, you're going to have him on the show.
That's right.
Talking about another area of secret technology where Tom Bearden has exquisite experience and expertise, the so-called myth of free energy. Tom?
Well, yes. As a matter of fact, the common assumption in electrodynamics is you can freely change the energy of a system anytime you want to. They call that regauging. And if you look in the Bible, so to speak, for classical electrodynamics by Jackson, you find out that they did that. As a matter of fact, to get the systems where you wouldn't have free energy, they re-gauge the system twice to force it into equilibrium, and that's what they put out, the modified equations. You can look right in Jackson and see. It's called applying the Lorentz condition. Lorentz taught us how to do that.
Tom, I'm going to ask you a straight-on question. I'd appreciate a straight-on answer. Over the years, I've had a lot of talk on this program about free energy.
Yes.
A lot of talk. And talk until you're sick of talk. I have had a standing challenge, and I would like to give it to you now and you can tell me why it hasn't been met. Somebody needs to bring me a free energy device, or I would even settle for a device that simply gives more energy than it receives, a toy. Let's say a toy that would put the Energizer Bunny 6 feet under. If I could see something like that, I could believe. I haven't seen so much as an over-unity toy. If there's free energy, where the hell is it?
Well, it's out there, and in fact, it's already known in the literature. Let me give you some examples. Anti-Stokes emission is always over unity. I don't know
what that is.
Okay, it's a kind of emission where you have a certain kind of medium. It occurs in chemistry, and it occurs in certain particular suspensions of particles. If you put in so much energy, like you fire a pulse of a laser in there, the darn medium gives you back out a tremendous burst of energy. And by the way, the common name for this, they use a funny name for it, Letakov started it, I guess, is negative absorption. Which means excess radiation.
All right, this is all very interesting, but where the hell...
more energy back out than you put in. And, for example, Lewandowski has several patents on this. He has a nice paper in Nature, and the experiment's fairly simple. You take a little beaker, you put in some fluorescent dye, you hit it with a little laser pulse, you get a little warm glow. Then you do one little change, one simple thing. Into that beaker of water, of solution, you now put in some titanium dioxide particles. That's the main ingredient in white paint. So, and now you come back and you hit it with that same little laser pulse again, and you don't get a little warm glow now. You get a violent burst of light that fills the whole room. It's called lacing without population inversion.
All right. I don't understand a word of that. When we get back, I'm going to try the same question all over again. I'm going to take on faith what Tom just told me. And all I'm asking, again, is if any of this is true, and I'm not doubting it, I'm just saying, where is even a simple little toy that we can mass market and change the way the world thinks about energy? It's not such a tough request. Or is it? This is Coast to Coast AM. Back now to my two guests, and it's Tom Bearden, who is a nuclear engineer, and Richard C. Hoagland, and if you're even a casual listener to the show, you know who he is. So, gentlemen, we're back on...
You were proposing that if free energy existed, there should be a toy.
At least a toy. In other words, if all of this theory is correct, then we can change the way the world thinks. We can literally, in a very short span of time, we can make everybody rethink everything and publicly admit everything, and all we need is one stinking little toy.
Well, you have two problems.
Yes.
One is believability. Remember, the textbooks have been wrong for the last 100-plus years. That's what I've been saying. That's what Tom is saying. That's why we're putting the original Maxwell on the web so people can see, physicists can see where they've gone wrong.
Yes.
Number two, suppression. We haven't raised the ugly word, the S word, or the C word, about a group of people who do not want you to have this physics and technology, because if you did, they would lose power. And power groups are nothing new. Machiavelli talked about them. The history of the human race is filled with them. Knowledge is power, and this is the ultimate power in knowledge.
But as you are not inclined to jump to the C word, and I agree with you on that score with regard to the death, untimely, sad death of John Holloman, I'm not inclined to jump to it here until I see something. I mean,
but
what
Tom
would stop...
gave you a stunning example. What Tom can list for you if we have the rest of the evening...
But I don't understand...
Wait. But he could list for you umpteen laboratory experiment after a laboratory experiment which demonstrates unequivocally.
I know.
Well, but wait, what's the magic connection between a laboratory experiment and a marketable product? What's the missing puzzle piece? So you don't have your toy.
No, you tell me.
It's called money. If an inventor wants to put something on the market, he has to go to somebody to get the money to do it.
Yeah.
The money is controlled. That's the way you control science and technology. You control the money. You can have all the theory in the world. If it doesn't get translated through the monetary system, through the free market system, to an actual producing device with, in assembly lines and production and distribution, you're not going to get it into the hands of the consumer. And over and over and over again, there have been these interesting little impediments. Now, what's going to happen Friday night when you get Steve Greer on? He's got a company which has potentially a good free energy device, and they are completely reversing the normal market procedure to get this into the hands of the public. And that's what he's going to talk about. These people don't want to make $1 billion in their spare time. Greed is apparently not in their lexicon. They're doing it right. Now, let me go back to the toy thing. We have a toy which demonstrates hyperdimensional physics, and a good friend of mine, Steve Troy, just called me and pointed it out.
What is it?
You have one sitting on your shelf there somewhere. The Levitron.
I have the Levitron, yes.
The Levitron, bingo! Now, that's crazy, because the Earth's gravitational field is constant.
Actually, you're right about that, and they say in the instructions and the videotape by the inventor of Levitron that they don't exactly understand why this is.
Isn't that special?
Yeah, it's true.
Well, that's what it is. You got your toy.
Well, no, you really don't. At least you're going to have to explain to me how. In other words, eventually the friction of air will cause the Levitron to slow, as standard physics suggests.
Oh, sure,
it should.
but no. What you have to do is, if you spin the thing at 9 o'clock in the morning, by 9:30 or 10 o'clock, you got to put on one of those little washers, or take one of those little washers off, because you can't make it spin the way it's spun at 9.
That's right.
At 10 it's different, at 11 it's different, at 12 it's different,
That's
at
right.
dawn it's different.
The Levitron is a little toy that actually levitates a spinning top in midair. It's a most amazing
it
thing you've ever
uses
seen.
a opposite like pole magnetic field to float, but the field is constant.
Yeah, it shouldn't
And
really
the
work.
spinning is constant. The damn thing, nothing should change, yet you have to keep changing the weights. Well, this was the first dead giveaway that I had found my first hyperdimensional demonstration. And I found it at a Star Trek convention where Kate Mulgrew was appearing, which is why I went there, because I really, I'm a fan of Kate's. And lo and behold, some physicist had put out in the Northwest this little toy, and I got one, and the rest is history. Now, this is a hyperdimensional toy. You should not have to keep changing the weight.
Okay, maybe, but I still want something that will produce more energy, either free energy, which means no input, or I'll even settle for over unity. And I know you can quote me all kinds of things that I won't understand. All I want is one little thing that will prove easily to the general public, the Energizer Bunny falls on his butt, this thing keeps going.
Well, wait,
Let me give you one.
All right.
Let me first preface this by saying it's real weird, but every electrodynamicist in the Western world already teaches the use of perpetual motion machines. They really do. They assume that the potentials and the fields are due to source charges.
You're going to lose us quick.
No,
Where?
a little
Give me
charged particle, a little piece of charged mass.
Give us an example of a perpetual motion machine.
Okay, I'm going to get to that. They already assume that if I have electric fields that they say exist out here in space, or if I have the potential, the voltage that comes off of this thing, it's coming from this little source particle. In other words, they assume the little source particle creates all the energy in that field and that potential that reaches all the way across the universe in every direction, puts all that energy and pours it out in there. They assume that that little charged particle creates that right out of the thin air. That's what is assumed in electrodynamics in every university and every textbook in the United States. So, boy, do they ever have little perpetual motion machines that generate energy from nothing. Now, if you go to particle physics, see, sometimes the disciplines don't talk to each other very well. If you go to particle physics, they solved that problem, 40 years ago. What happens is the little charged particle, a little electron, a proton, whatever, is in a violent energy exchange all the time with the vacuum. The vacuum is filled with energy running every which way. It's very energetic. By the way, the U.S. Patent Office has now accepted the vacuum itself as a source of energy. They've issued patents with that in it. One to a fellow that I know, Dr. Frank Mead. So it is in this violent energy exchange. It's absorbing energy from the vacuum all the time, and it's re-radiating energy back to the vacuum. So we already have every little charge is already gating energy right out of the vacuum and already producing an energy outflow. So do we have free energy machines? You betcha. It's called an electric charge or a magnetic charge. Every cotton-picking one of them does it. And both the electrodynamicists and the particle physicists will both admit it. But the particle physicists will tell you the energy is being taken from the vacuum and re-radiated or gated from the vacuum by the charge. The electrodynamicist is still back in 1864, and he tells you the charge just creates the energy out of nothing and pours it out into space, creates it out of thin air, and violates the conservation of energy law. So you see, science has got a lot of holes in it, in the foundations, and that's the problem that's really stopped free energy machines. They keep beating you on the head with all these holes in there. You have to first turn around and sort out the models that they put on your head that will not allow any such machine to be built if you built it by that model, and find out what's wrong with that model. Now, it turns out the models do have the holes, and they do have the errors. I've got one chart with 32 major errors in electrodynamics in it that's being taught from the platform in all the universities. And Foundations physicists have been pointing this out for decades, that this stuff needs overhaul and needs redoing. My goodness, that stuff got started during the American Civil War. 1864 is when the basic paper was done, and the basic equations haven't been changed since then. Even though we've learned an awful lot, and we've learned that a lot of that stuff is not exactly that way, but we've never gone back and changed the equations.
All right, let me try another example that may bring it down to home. You're sitting there at the console tonight down there in Pahrump, right?
Right.
If you were to take, let's say, a book or something heavy on your console,
right,
and hold it straight out in your hand,
yes,
how long could you sit there and hold it straight out before it got heavier and heavier, and your muscles got tired and they began to vibrate, and you dropped it?
I don't know. Is this before or after the near-deck experience?
It doesn't matter, okay?
All right, not long.
Not long, okay. Now, take a little tiny magnet. Any little magnet you can pick up, one of these refrigerator magnets, okay?
Right.
And put a paper clip on it.
Right.
So that the paper clip is hanging over empty space.
Right.
How long will the paper clip remain attached to the magnet?
Well,
held up against gravity.
Virtually
indefinitely.
Indefinitely, yeah.
Why? Where is the damn energy coming from? It's not in the little magnet.
Look, that's easily a third-level question. You don't ask me those. I ask you those.
There you go.
No, Art, these are not tricks. The idea is that we have been run by authority figures who've been telling us the world works a certain way. They've been lying to us. Most of them have been lying to themselves because they haven't gone back to Maxwell. They haven't been able to go back to Maxwell. But in fact, the world doesn't work the way the theoreticians have been telling us, and therefore when you try to take a device to market, to patent, if the theoreticians are the gatekeepers, it can't work because the laws say it doesn't work, forget reality, forget the fact that the magnet is going to hold the paperclip up forever, so the energy's got to be coming from some other unknown source, non-dimensional source. The device can't work, you don't get the patent, you don't get the money, you don't get it to market, it doesn't get into the hands of people. Period. End of discussion. And that's why what Steve is going to present to you on Friday night is so mind-blowing. Because you got a bunch of people who want to basically give it away. So it gets into the hands of people, including one Art Bell.
Well, that's nice. I believe when I see Richard, they have these free energy symposiums and demonstrations all over the country. I hear about them all the time, but not one has turned into one. You know, they always have a little black box, and unfortunately they don't want to give away their secrets, so you can't look in there.
Well, these guys, I was told, and that's why I came to you with this, were different. They are willing to provide this for free and to give you a damn one that lets run and run and run and run and run. So hold Greer's feet to the fire Friday night.
Boy, now you're cooking. Or Greer is, or so whoever this is cooking. That's what I need.
Let me give you a little insight into that. We have a group of 8 guys that I'm working with, and in the energy field. We filed several patents. We do not have a working model. I'll say that right off the top at the front.
A working model of
a free energy machine. We've still filed the patents because we have the processes. Now, what we intend to do when we do have a working model, and we intend to have one, when we do have one, it's not sufficient just to produce a model. What we will do, there is a thing called a government-certified test laboratory.
Yes.
All the aerospace firms use this. When you fulfill a government contract, they don't want just your guys to say, oh, it tests great. They have an independent certified lab with excellent test engineers who specialize in that field, and they do the testing, and then they certify it to the government that this thing tested this fashion today. So they don't take just your word. They get this independent certified test lab who gives you what specs it's tested to and the procedures that are used, the calibration of the instrument, everything. Now, the proper procedure, as far as we're concerned, in our group of 8 guys, is when we do succeed in having a working model, we have out here in Huntsville a very excellent laboratory that's a government-certified test laboratory with an international reputation, Wiley Test Labs. And our first step after having the working model and filing the patent will be to stop at Wiley Labs and pay for an independent certification test. The reason is very simple. That test will stand up in court, and it's accepted by the U.S. Patent Office. So that's the way to proceed. Forget the secrecy, and I got a secret gimmick here that nobody knows to do it. Do it straightforward. If you understand how it works, and many of the inventors don't, even when they succeed from time to time, explain it the best way you can. Have it tested in a certified test laboratory. Now, they're going to test inputs and outputs. That's exactly what they're going to test. How much energy you got to put in, how much you get out.
That's right.
And they're going to certify it that with the state-of-the-art instruments and state-of-the-art test engineers, this thing tested that way today to all the specifications that apply. When you get that, you've got something that you can go to the U.S. Patent Office in, and they will accept that and grant your patent. And that's exactly the way we plan to do it, and I would recommend that all the other inventors who are legitimate and not trying to do a stock scam, my goodness, if we'd wanted to get well, you know, we could have got rich a long time ago by selling stock and, you know, making a nice smooth statement and all this kind of stuff. We're not going to do that. We have a closely held corporation. The stock is not for sale.
But, Tom, this is one of the things that has always bothered me. We are a capitalistic country. We're basically greedy. Some said during the 80s, greed is good. I mean, that's the way we are. Whether we like it or not, we love to make a lot of money, and anybody who would come up with this would be a gazillionaire. And so,
of course, if you do it legitimately, you don't really have to worry about the money. Now, what you do have to worry about, I hate to mention the C word, but there is a C word to be mentioned in this area. Up until about 10, 15 years ago, you could get yourself killed real easy in this country.
Well, and so you're going to send me a machine, huh?
I will when I get one.
Well, no, I mean, here's Richard saying that Stephen Greer has one.
The engineering group that he's involved with has one, and hopefully they're going to make more, and they're going to send me one too, okay?
All right, there's already enough suits coming out to Pahrump as it is. Don't laugh. I'm serious. If what you're saying is real, then the danger is real.
Yeah, but the visibility is realer. The problem has been, and I've been trying to tell these free energy folks for years, if you try to be greedy and try to make $1 billion in your basement in your spare time, it will never work.
A lot of times, sometimes it's the inventor, but sometimes it's not the inventor. Let me shed a little light on that. Quite often, the inventor, to keep going, you know, it's just like a scientist. All science is patronized, and so are inventors. Somebody funds this stuff.
Sure.
And he's got a backer. Well, a lot of your backers are greedy as can be. And, you know, they don't understand anything scientific, but they want to make that $1 billion tomorrow, and they don't mind engaging in a stock scam. So you got a terrible problem if you have a backer and suddenly turn around and find out this guy doesn't care where it works or not, what he wants to do is sell stock and
so you're telling me
make a lot of money.
You're telling me there have been so many frauds that you're making the case that when something real comes along,
you won't even recognize it by the guys who specialize in going around.
Well, that might be true.
Something up and making it a
okay,
stock.
And that might be true in the sense that I have always said, and I'll say again now, that if person X with absolutely what he considered to be irrefutable proof came forward and got on a podium and said, here's the real story of how Kennedy was killed, it would simply be piled on the thousands of theories that are already out there, and nobody would pay any attention to it whatsoever.
That's correct.
And how long, Art, has it taken me, and how many shows have we done, before you get mathematicians and physicists commenting on this paper saying,
it's true,
you know, he may really be onto something.
Yeah, it's true.
Now, in the world of C, you know, the suppression world, you don't go to the inventor. You don't threaten to break his legs. What you do is you go to the money sources who might provide him the money, who usually have a lot of money, and you say, look, if you put money into this, you're going to lose your money over here.
All right, look, we're at the top of the hour. You're going to have to hold it right there. I want everybody to get up to my website.
Talk with Art Bell in the Kingdom of Nye. From east of the Rockies, dial 1-800-825-5033. 1-800-825-5033. West of the Rockies, including Montana, Wyoming, Colorado, and New Mexico, 1-800-618-8255. 1-800-618-8255. Now again, here's Art Bell.
Once again, here I am, Tom Bearden, who is a nuclear engineer, a retired lieutenant colonel from the Army, is my guest. Richard C. Hoagland is here, but he's been here for years, and so I don't have to reintroduce him. At least I shouldn't have to. They will both be back in a moment. We've got a couple of things to cover. One to correct, I think, and then one to cover, and we're going to then open the phone lines. Now I'll say it. All right, gentlemen, welcome back. I guess first let us correct something. I said that the Soviets blew up the Thresher, and you said, well, no, not exactly, Tom, and you want to explain that?
Yes, what they did is they simply put an interference zone directly on the Thresher so that normal electromagnetic energy appeared in their controls, jamming the electrical controls, so the sub would not respond to the controls. They simply couldn't direct it to come back up. So being helpless and without any control, they just sank to crush depth, and the hull imploded. All right.
May I bring up something?
Absolutely.
Just let me say two things, and either one of you can comment or not. Flight 800, Swiss Air Flight 111. Now, if you can do that to a submarine, what can you do to an aircraft that is controlled, basically, electronically?
Well, you can easily shoot it down, and they've shot down several. The Arrow DC-8 at Gander, Newfoundland was a direct kill. There's all kind of signatures on that, including an eyewitness that actually saw the streak come down and hit the aircraft. And the hole is in the right fuselage ahead of the wings. They found the hole, tested it. There's no explosive residues on it. So they killed that in December the 12th, 1985.
Whew.
There was a whole series of tests in 85 and 86 where they killed aircraft and missiles.
I mean, the allegations you're making are so serious, I'm just blown away.
Sure. Well, it's been going on for decades, you know. It's no problem to identify the incidents if you look at them. I gathered from the open literature. This was done my own time and, my own efforts, and I might say also out of my own pocket. But I was able to gather literally 100 to 200 incidents of testing of the weapons clearly recognizable, and including shooting down airplanes. The Thresher was one. It had signatures on it that made it, it identified what did it. The one thing that was a clear signature on the Thresher was that its surface companion, when you're creating all this energy in this big interference zone, well, the surface companion's in that interference zone, so he's got to have the same effects. And it did.
And it did.
The USS Skylark was the surface companion, and they were trying to send an emergency message back to the Navy, and they couldn't even get the message back for about an hour and a half. They were so jammed, and their systems wouldn't work. All kinds of electronic systems wouldn't work. So they had the same effects on the surface. That tells you right away you got something very unusual going on.
All right, there's a very important companion anomaly, which will segue into the next area that I want to bring up. What's the most common report from close encounter UFO activity from the 50s and 60s?
Car engines stopping, electromagnetic disturbance of various sorts.
Precisely. Because if you create this technology in another form, which is basically anti-gravity or electrogravitics, the side effects on normal EM systems is to stop them, to interfere with them, et cetera, et cetera. In other words, very similar to what Tom says was done by our guys, meaning the Russians, to the Thresher back in '63, which then brings us back to the anti-gravity. I have shown you some videotape from STS-80.
That's right.
I've shown you videotape from STS-48. You have seen the Mexico City footage from a year or so ago.
Absolutely.
At the conference in Seattle, one of the things we're going to do is to not only show these videos, but show them in close-up and now take them apart. Some of the analyses I've been promising for a long time will be done, including the close-ups and the time-corrected motions of the UFOs photographed over Mexico City at 19.5, I might say. And these all turn out to be electrogravitic technology vehicles, which are not only readily photographed by, two NASA missions and now by the Mexicans who photographed the stuff in Mexico City, but it's strongly looking now as if some of this stuff could be our own technology. More black programs, which we must drag out into the light if we're going to affect things like what's going to happen in November. And one of the things that Tom has promised to do is to back me up theoretically, because apparently he and a collaborator actually managed to produce a remarkable negative gravitational effect in the lab in one of their own experiments a few years ago.
Wow.
Well, first of all, let me say, I don't have any information, yes or no, that we have such a technology or anybody else. Now, I'm willing to entertain the idea that somebody has. Now, what I can tell you is I worked with an inventor named Floyd Sweet off and on for about 8 years. And Floyd had a device which really was a legitimate over-unity device, but it also affected gravity. That is, it got lighter. The more power that you put out with it, the thing would lighten its weight. So I took a look at that, and I had my own theory of gravitation anyway, and I got Floyd to do an experiment, because that was the only device I knew anywhere that could do such an experiment. It's based on the fact that Maxwell left out half of the electromagnetics and half the energy. Now, that's fairly easy to show. He only accounted for half of it. Let's just take that as an assumption for a moment. The missing half is a time-reversed half, and what it does, it interacts in the nucleus. The part that he gathered is the part that interacts with the electron shells, and all our instruments are electron wiggle detectors. So we measure that half, and it agrees with our theory, which predicts what's going to happen to those electrons. And we just simply roll our eyes in physics and say, oh, yes, Newton told us that the nucleus down here is going to miraculously recoil. This force is going to appear on it just out of nowhere, and it's going to recoil at the same time. We know that. We got a name for it. We haven't got the foggiest notion what causes it. Well, what happens is that nucleus recoils every single time you get those electrons stirred up with equal and opposite energy. So Maxwell left out that half. Well, I took a look at that, and I said, then we got this missing half wave, And that means that in its negative energy, gravitation is known to be, gravity is known to be negative energy. And that would correspond with time-reversed energy. And since his device was using that kind of energy, I said, well, let's suppose we can interact with excess of that energy coming in and repel it before it actually gets in to interact with the nucleus. Then that has to generate anti-gravity. In other words, take what's generating the gravity, break it up so it doesn't happen and repel it in the opposite direction, and that's a rough way of saying that would be anti-gravity. But we needed an experiment. And his device was the only thing could do that. So Floyd actually did the experiment. And for a load, he used 10 light bulbs, and he just screwed one light bulb in after the other, and had the thing sitting on a nice scale on the laboratory bench and was weighing it. And it steadily lost weight. Every time another light bulb went in to draw more of the energy away before it got to the nuclei in the atoms of the machine itself, the machine got lighter. And it lost 90% of its weight very smoothly and very controllably sitting on the lab bench. Now, we actually got this published in a paper. Since the invention was not mine, I believe in giving credit to where the credit goes. I wrote the paper, but I put Floyd's name first because he was the inventor, and that was proper. But we did get it published in an ICAC proceedings. And of all things, they published the paper. So, ironically, we got the results published of really what today, as far as I know, is the only real, honest-to-God, 90% reduction of weight in the laboratory under controlled conditions. We did get the paper published. Unfortunately, Floyd died, and that was the end of that. But we did do the experiment, and it did work just like that. We took everything that would make gravity and said if we can reverse that and prevent it from striking the nucleus and generating that Newtonian third law, and direct it out there in the load and use it in the load, then the machine has to get lighter, and it did. So can the technology be done based on that experiment? Of course it can be done. It can be done electrogravitationally, and the key is electrodynamics. But you've got to take into account a whole missing half of electrodynamics that Maxwell omitted. He omitted the part that splits off and goes down in the nucleus and generates that Newtonian third law reaction. And that's what Whittaker supplies. And Whittaker shows you what the two parts are.
All right. And you gentlemen now say that all of this has application in medicine as well, don't you?
Yes. Again, I did about 14 years' work. That was a terrible thing to break. On the priori effort that occurred in France, funded by the French government. By the way, it's in the hard French literature, so it's there. Anybody can go check to see that this actually occurred. Priori discovered a very remarkable way to heal. Basically, it turns out, to make a long story short, if you, in theory we have today for time reversal of waves, if you pump with transverse waves and you have a nonlinear mass, it'll respond to another input wave that you put in. It'll respond by generating a sort of a crawfish wave that'll back up exactly where this other wave came through space, even through a very tortuous route.
Like a mirror image.
It's retro-reflection, but very precise retro-reflection. And it'll do it at an awful long distance, too. It'll just appear everywhere in space back there that this other wave came and occupied. It turns out, after 14 years' work, that if you pump a living cell, the mass, with longitudinal waves, not with transverse waves, what you do is you do not make this reversed wave, you reverse the mass itself. Now, in biology, that's called a de-differentiation, going back to an earlier state. And what you do is you just back the cell back up to when it was a earlier and healthy state. Now, this thing actually worked. He worked on it all through and demonstrated in hundreds and hundreds and hundreds of lab experiments with eminent scientists working with him under rigorous controls. For example, it was reported to the French Academy of Sciences by Robert Courier, the head of the biology section of the French Academy. And Potruzel worked with him, who was a world-renowned parasitologist. So these were excellent scientists of first caliber working with priori, and nobody could understand how this thing was working. And that's what he was doing. He was making longitudinal waves and pumping the whole body, all the cells in the body. Well, if it was a normal cell, they just got a little younger. That's okay. But if it was a disease cell, it would back up, genetics and all. He cured arteriosclerosis. He cured cancer and grafted terminal tumors on the lab animals. He cured infectious diseases, all kinds of things. And after looking at that, that's what it turned out to be. He was making longitudinal waves, and when you pump a mass with longitudinal waves, you can time reverse the mass.
And I suppose that we get to the exact same C word when we ask where...
No, you don't. There's not really, so far as I know, not a conspiracy. What there is the standard thing that goes in the scientific community, not invented here, and it's the greatest scientific jealousy you ever heard of. And suppression comes from the dogma in science. It's not a conspiracy from without that says you're not going to do this. It says science itself. The people who would no longer be the experts react not kindly to that at all. And so the scientists suppressed it.
There is a stunning paper trail on this, including the politics of the French Assembly and the Premier. See, Priori was a veteran of World War II. He joined the resistance. He was an Italian inventor who worked with radar. And he made very good friends with a whole bunch of French folks that then wound up being in charge of the government in the 50s and 60s.
Well, what happened is he was captured when Italy sort of began to bow out of the war. The Germans didn't treat him too kindly, and so they took him back to France and put him into slave labor, although he was an Italian radar engineer. And then they decided they were going to kill him. Well, the French underground had a raid and freed him, set him free, and some other folks in there too. But anyway, the rest of the war, he fought with the French underground against the Nazis. Now, some of the people that were in that underground with him while he was fighting the Nazis during the latter part of the war later became very high French officials. One of them became the prime minister. And so when he started to doing his experiments, he had enough power of his personal friends in the government that the French government funded his work. The reason the thing got suppressed was in the early 70s, the French government fell, and the leftist government took over. And, of course, all his friends were out of office.
Right.
And at that point, they got him. They suppressed the whole effort. But he actually did that, literally stunning experiments and rigorous controls. I mean, for example, Courier sent his personal PhD assistant, a very fine lady biologist, down to personally do the graphs on the animals to ensure that everything was done with meticulous care and as fine as could be done by the very best. And the work was unexplainable because nobody knew anything about longitudinal waves, much less time reversing a mass. Only in biology you would call it de-differentiation back to an earlier state.
Well,
de-differentiation is known. Becker in this country did that.
Tom, let me stop you and ask you a question. It seems like the right place to ask it. Somebody in email sent me a summary, or said there is a website with a summary of your contributions and claims, and one of the claims, according to that site, is that the Russian Scalar electromagnetic weapons appear to be involved in UFO abductions and reports of cattle mutilations.
Well, no, I don't think the scalar weapons are involved in that. By the way, the Russians call them energetics weapons. And what they're involved in, they definitely generated the Gulf War syndrome, in my opinion. I think I can generate the mechanism that did that. And I think the signatures are there. So
anyway, it was not done.
Those men that were sick and are still sick today, it was not in their heads, and it was not just a whiff of a few chemicals. They were casualties of war. They were wounded and should be regarded as such, not with this terrible treatment they've had at the hands of the government.
It was these kinds of waves that we're talking about that did that.
If you do this incorrectly, or if you deliberately do it incorrectly, what Tom, with Priori's device and all those papers in the literature, which, by the way, are going to be linked through our website, ultimately. There are some...
Well, if you believe one, you can believe the other. In other words, if you believe it,
you can use it as the ultimate biological weapon.
That would make sense.
And you can also...
But Tom is saying not only can you, but it was done.
It's being done today. I've gone on record officially saying it. I have action papers right now. We'll not discuss them. in our own government, trying to convince our own government, hey, guys, wake up and smell the roses. This was done to our fellows in the Gulf War. This was not something that just happened to them by a few parasites.
Well, we must assume they know that.
Well, I don't think they do. And the reason I don't think they do is that our own scientific community, for some reason that I cannot figure out, defends this classical electrodynamics, which dates back to 1864. They defend that as if it came down on the stone tablets with Moses off the mountain.
All right, listen, we're at the bottom.
Dogma.
I understand. We're at the bottom of the hour. Hold on, we'll be right back. Tom Bearden, Richard, upon the air together again. All right, gentlemen, I would like to allow the audience to ask some questions now, if you wouldn't mind.
Well, I'd just like to make one little statement, okay?
Yes, one little statement.
This has been a very complicated evening.
Yes.
We have ranged across absolute vastness of thought and implication.
Yes.
And we haven't been able to really substantiate a lot. But the bottom line here is that if Tom's experiments and theoretical work is right, and my work for the last 15 years based on Sidonia is right, they have converged on a stunning potential for a new future that is unimaginable. The literally re-engineering of reality.
Yeah.
I mean, in the last segment, we were talking about curing diseases like cancer, but Tom slipped in a phrase that I don't think anybody picked up on, which is he's talking about reversing the aging of the cells.
I heard that.
Art, how would you like to live 1,000 years? Or 10,000?
Actually, that's a very controversial question.
Well, but the point is that we have a future now within our hands. If we want it, we can have it, provided we get it out of the black world, who's got it and won't let us have it.
Well, if it's possible, there ought to be plenty of people in the black world living 1,000 years.
How do you know they aren't?
I don't.
Exactly.
I don't. But, I've got to say, you were correct when you say this has been an extremely wide-ranging show with incredible statements and allegations made and no absolute proof.
And some of the follow-up we will be doing in Seattle this coming weekend.
All right. Here come. Look, I can't hold them off.
Go ahead.
I promise calls. Here come calls. West of the Rockies, you're on the air with Tom Bearden and Richard C. Hoagland. Hello.
Hello.
Hello there. Where are you, sir?
Hi, I'm Sean, and I'm calling from Mililani, Hawaii.
Oh, Hawaii. Excellent. You're going to have to yell at us a little bit. You're not too strong. Go ahead.
Well, I just wanted to make that same observation, Art. It seems like every time you have a guest like Mr. Hoagland on, they come up with the wildest claims, and they can quote so-and-so's study, which we never ever see, and it's right up there with the creationists. You know, they never have any proof.
Sir, let me stop you. All right, do you have a computer?
Yeah, I'm playing on it right now.
All right, go to my website. Download that hyperdimensional paper and read it.
Well,
look at the Whittaker papers attached to it.
It's not proof, though.
Well, what is proof in your reality?
Well, proof is something where you've got to substantiate it using the scientific method.
Okay, let me answer that. Number one, take superpotential theory, which was sparked and initiated by that 1904 Whittaker paper. It's used in all the cavity resonance and all the devices they build like that in waveguide theory for building waveguides and all. It has a very practical use. So, is it proven? You betcha.
Well, not to the extent that you guys.
Not at all, because who messes with it? Only those guys building waveguides and only those guys doing cavity resonance.
Well, you see.
What we're saying is, we got a perfectly good thing over here working on a lab bench. It works that way, so why not use it in the rest of the world?
Well, you keep saying you've got things like perpetual energy machines.
Well, it's not me making the assumption of perpetual motion. That's the classical electrodynamicists who make it. They taught you that a single electrical charge continues to pour out energy forever. Forever and ever and ever.
You're making blanket statements.
No, I'm not. That's a common assumption when I took classical electrodynamics in university.
Wait,
it's in every book. I've got a library of books looking at me here with that in them.
You said they do exist.
And, nobody realizes what's in this stuff. Nobody realizes that they regauge the equations. Nobody realizes that They went down from quaternions, which is a higher topology algebra, which is what Maxwell wrote it in, down to vectors. Oliver Heaviside is the main person that did that. And that's a much lower topology algebra.
Words if you want to, but you said.
Why don't you go look on the Los Alamos National Laboratory site and download the papers on longitudinal waves by a whole host of bright young physicists, and I assure you they wouldn't be on that site if there wasn't some experimental evidence behind it.
All right, I'll tell you what I'll do.
Check the literature.
Caller, do me a favor and do that. Go ahead and download that, read it, and then you call me back.
Well, Art, it's like reading the Bible. He still can't prove it.
You mean Los Alamos doesn't stand behind what they publish? I don't think you're right, sir.
Well, I'm saying...
I think you better go back to school.
when you make a statement that these machines do exist, you can't prove it.
Caller, I'm kind of on your side. So I'm saying do me a favor. Go download that, read it, and then come back and say...
Let me answer that question. Can I prove it? Let me give you some proof.
And say I still feel the same way. Would you do that for me?
Well, Art, I've listened to Mr. Hoagland and some of these other guys so many times.
Yeah, but now you're getting to be very general, and they did make a specific request. All I'm asking is read what he asked,
check the literature,
and then come back and tell me if you still feel the same way.
Well,
do you know what a longitudinal wave is or how to make one?
Well, I've been listening to you all night, and I haven't heard anything that's substantiable yet. So.
I hear those general words. I ask you a very specific question. Do you personally know how to make a longitudinal wave?
Absolutely not.
Okay. You just answered your own question.
Yeah, in a way you did. In other words, reach out, touch, do some reading, and then come back to us again, please. First-time caller line, you're on the air with Tom Bearden and Richard C. Hoagland. Hello.
Hi, Tom, Richard, and Art. This is Brian on 6:30 a.m. KHOW in Denver.
Well, that's just where I was this last weekend.
Yep. I'm sorry I missed your book signing. I really wanted to go, but...
Well, check out the photos. It's cool.
Okay.
Anyway.
I had a question about the variation in the speed of light.
Oh, yes.
And this question kind of leads into another one. What kind of, magnitude of variation are we talking about? How much change has been observed?
There are a series of papers that I'm going to link on our website. I didn't have time tonight because I had to go searching for them, and they originally came through a physicist who I worked with at SRI International, Lambert Dolphin, who has very carefully collected these anomalies and has put them on a site that we're going to link to. And what they've been doing, some of the physicists, including some folks in Australia, have been doing is taking reports going all the way back to Bradley and Romer, back in the 1600s, when the speed of light was first measured by noting the anomalies in the eclipses of Jupiter's moons. When Jupiter is on the far side of the sun from the Earth, light takes longer to get here than it does when we're on the same side. And the calculation of when the eclipses should occur went out of phase. In other words, it was obvious that the light was not moving at an infinite speed, but at some finite speed, and so the first measurements of the speed of light were done with telescopic observations of the eclipses of the satellites of Jupiter. Well, when you go back to the 1600s and look at all the experiments up to the present and apply a statistical analysis, it turns out that the speed of light has gone up and down in a semi-periodic fashion, like a sine wave, but with more complicated structure, over the last several hundred years, several dozens of times, by a few percent. And this is absolutely predicted by the hyperdimensional model, particularly the latter part of the paper, which is on my website, due to the phasings of the planets and their changes in the scalar potential of the overall solar system, the permeability and the permittivity of the vacuum.
Okay, let's say that we're experiencing changes in the speed of light or observing changes
that are
in the speed of
currently
light.
From 1987 forward is when John Anderson is finding these anomalies in the tracking of these spacecraft. Remember, they were moving outwards. The Pioneers started back in the early 70s. 73, Pioneer 10 was launched, and it's only since 87 that the anomalies have been showing up, which indicates it's not a permanent problem with the theory, it's a time variable problem, which is part of what the HD model predicts.
Okay, so how does that apply to the Einstein's theory where E equals mc squared? I mean, even a small change in the speed of light is going to make either huge changes in the energy total of the universe or huge changes in the mass total of the universe.
Tom?
Well, he has a point. What you have to do is you have to change a whole structure. You can't just change one little thing. But if the speed of light changes, if it is indeed changing, it implies that you've had some curvature effects in space-time. For example, speed of light in a flat space is one thing. The speed of light in a curved space is something else. So let me put it this way, the least that it implies is that there are some curvature effects in space-time occurring. Now, how they're occurring, if they're occurring by the sun changing its gravity or something, that's to be established by experiment. But they are saying that something is happening to the space-time, and the question is, what is causing that to happen? I personally don't know what's causing that to happen, but if the experiments show that it is happening, then there has to be a causative agent.
Remember, with the NASA data, you've got an anomaly which is unequivocal. It's there.
Yeah.
You've got one of two.
But it's, the two things conflict.
Exactly.
And that's the real puzzle. What is the causative agent that would give you one kind of effect, apparently, I'm saying apparently here because I have not read those papers, apparently on the surface of the Earth where you're doing experiments, and yet would give you something different out in space. Now, boy, that's a real anomaly. That one deserves full scientific attention.
If we can measure, like through interpolation of values and so forth, I'm not exactly sure how they do it, but they can kind of estimate the mass of the universe and so forth. Wouldn't they be seeing some kind of change in the mass of the universe as the speed of light changes, or that's assuming that the energy constant would be constant?
Well, you see in astronomy all the time, from the Hubble data, from the X-ray observatory data, from ground-based data, you see all kinds of wonderful little anomalies if you read these papers that are published carefully. But when you see popular accounts, or when you see official press conferences, all these little anomalies are all swept under the rug. And the real surprises of the universe are always in the anomalies, the things that don't fit.
I like to think of it by saying that while we may have, in some cases, very good models, the models are not perfect. I don't believe we have a perfect science yet. And I believe that what happens with anomalies, they show you either you have some other variables that you don't know about that are now starting to change and are affecting the situation itself. You have a piece of your model missing in that case. Or there's some additional cause that's entered the situation. You don't have an effect occur unless there's a cause. Otherwise, we've got to throw away the whole scientific regime. We believe in cause and effect. And so if we are having the effect, there's got to be a cause. So the question becomes, if the experiments are sufficient to say we have the anomalies for real, and particularly if they are also contradictory on where you're located, then the question becomes, we now have, let's say we accept the experiments, let's now ask the question, well, then what is the cause? First of all, you say, what's a possible range of causes? And then you go looking to see what, if anything, you can find that fits any of those that you can think of that would be possible causes of that. And that's really the way you have to attack the problem. And that's a problem of that magnitude should be attacked directly by the scientific community.
Tom and Art?
Yes.
As you know, I've been talking to some of these satellite operators now because of the Leonid meteor problem. And I got some information over the weekend from, again, another source who tells me that people like Hughes and others are getting increasingly concerned with orbital anomalies showing up in the tracking of the Earth-orbiting geosynchronous satellites, which are not conforming to the standard gravitational theory.
Yeah, I've been hearing some rumors about that in the
industry. And this will show up in antenna pointing and in your ability to stay on the air. If the gravity constants are changing like the lab data says it is, ultimately, in an orbiting situation, it's more sensitive just because the baselines are much bigger, much longer.
I've been hearing rumors, Richard.
Well, they're not rumors, and what I would appreciate is if you can track the rumors back, because our friend from Hawaii, you know, he listened to the entire night, and obviously he's throwing out the experimental observable anomalies because his universe doesn't permit them. But in fact, the real world tends to intrude a lot, and if the satellites are moving in a non-Newtonian fashion,
but let me stop you, Richard. Let me tell you why I can't get any confirmation of this. It's because those communication satellites, the ones we're talking about right now,
Yes.
are multiple hundreds of millions of dollars of hardware.
Yes.
Any unexplainable phenomena that's occurring to them
Yes.
is not going to be, unless they know what it is not going to be made public, not in a million years.
You wouldn't be bringing up the C word, would you?
I'm bringing up what I know to be true. What I know to be true. In the past, when there have been major
So that would just be CYA.
Well, yeah, when there's been major communications failures, the vendors of these satellites, and I won't name them, have lied their asses off. So I know they're not going to talk about it.
So there's a coherent suppression strategy for good old economics reasons.
Of course.
Okay.
I know that's true in this
Well,
case.
but the problem, Art, is it's going to get bigger and bigger. And I'll tell you an area it's going to affect is GPS, which, of course, is the area that Tom Van Flandern is working on hard. And it's also going to affect this new system, Iridium. And some night we're going to do a whole show on Iridium. The things I found out about Iridium and its reasons for existing have nothing to do with the reasons that have been stated. Nothing.
I know about Iridium. It is a constellation of satellites ostensibly to provide data and voice communication.
Yep. In low Earth orbit.
That's right.
Multiple planes.
That's right. As a matter of fact, there are many, many Iridium satellites already in the constellation. So what do you know?
It has another reason and another purpose to exist other than its stated purpose.
Which is? Come on.
Well, disaster. It is the ultimate fallback for disaster.
What do you mean?
I mean disaster. If major problems occur, as the physics changes, we've discussed so-called Earth changes, right?
Yep.
Well, as Earth changes progress with a changing physics, you need a absolutely surefire mechanism of point-to-point communications. You can't depend on landlines, and you won't be able to depend on the geosynchronous satellites because they've been too exposed. So Iridium, and there's other stuff we could bring in later on, is this backup. And
Wow.
You cannot go and buy commercially an Iridium contract. We've tried. We wanted to do a beta test for the trip that we're discussing to Egypt in December 31 of this year. We cannot walk in the front door and buy an Iridium contract. And other people who tried on our behalf are being mysteriously stonewalled.
Very interesting.
The system ostensibly wanting commercial customers.
There is a lot of unusual, I'm not even sure what the right word is. There's some pretty strange stuff going on with Iridium. I've known about it for a couple of years now.
No, it's not what it is.
Anyway, that'll be for another show. We're so out of time. Wildcard line, I think we might have time for you. You're on the air. Hi.
Hi, I just had a little nitpick with something that Richard said about the levitron supposedly revealing variations in the Earth's gravitational field.
Yes.
Why were you implying you had to resort to hyperdimensional physics in order to explain this? Was that your application?
Yes.
Well, why wouldn't just the moon that causes the tides and the influence of the moon and the sun affect the gravitational constant on the surface of the Earth at different times of the day?
Sufficiently changing to cause you have to change those weights.
Right.
That's a good question, Richard.
Well, because you're only a few inches off the surface of the Earth. The tidal forces go as 1 over r cubed, so you can do the calculation, and those are absolutely insignificant.
Very good answer.
Thank you.
Yeah, very good answer. Then it's so good, we might actually have time for another, and so unusual. West of the Rockies, you're on the air. Hi.
How you doing?
Okay, got to be
Great.
quick because we're running out of time.
Okay, well, I'm still trying to pick my jaw up off the ground. I wasn't sure if I didn't tap into a session of Science Weekly or something.
Call us toll-free at 1-800-618-8255.
Doug, we only allow... Doug.
Nels Hole. Hey,
Doug.
Yes, sir.
Only first names on the air.
Oh.
If you have a question, ask it quick.
Sorry.
That's all right.
Well, hopefully nobody can pronounce my last name.
All right.
The waves you're talking about, I know that's an extremely involved thing, but like the little metal balls that tinker back and forth, and I built rocket kits and so forth. Why can't the common man, the public, ever see any of this
technology. We're back to the same old question with what's going to have to be the same old answer, and we don't have time for the same old answer because we're out of time altogether. So, Richard and Tom, thank you both for being here. We're going to have to obviously do this again, but we're out of time. So, thank you both.
As ever, Art.
Thank you, Art. It was a pleasure.
Yeah, good night. What a provocative program. What a very provocative program. Well, that's it. Sorry, we're out of time. That's all there is. From the high desert, I'm Art Bell. Good night.